let's get started. First thing we're going to need is we're going to need a Pycharm. Okay, so let me share my screen. 1 second. Can you guys see my entire screen? Somebody's saying, yep. How is it possible to make it a little louder? Maybe if I move in, but you guys get to see me up close and personal. Okay. So here we go. First thing we're going to need is we're going to need an application called Pycharm. Now, for me, I already have it installed. So for me, it kind of looks like this, right? So it's this PC application. Now, if you don't have it, not a problem. It's a free application. What you would do is you would go to your favorite browser, any browser, and type in PY and then charm, right, as one word, so Pycharm. And usually the very first, search result that comes back, that's going to be essentially what you want. So as you guys can see, if you type in Pycharm, it comes back, and actually right here you even have a direct link to download Pycharm. So if you go there, I'm going to do it with you guys. So if you go there, I'm going to move this out of the way, but hopefully I don't miss any of your questions. Then let's see, make this smaller. Do it this way. There we go. There's going to be 2 buttons, okay? And there's one here, it's blue, and so it's very intuitive for people to click on the blue button. You don't want to do that, okay? You want to click on the black. And the black one is free open source. Now, they both say free under it, so, you're kind of like, but this says trial. So that means you only have 30 days. This one, however, you get to keep forever. It's free forever. So go ahead and click on that link. And this website is smart, so it's actually able to figure out what kind of computer you have, and it will start downloading. And it's a pretty quick download. It's about 5 minutes to download. So, just go ahead and click now, and then while I'm talking, you guys will be downloading to your computer. So that's the first step. Now, of course, I already have Pycharm, as you guys can see. So for me, let's see. I'm just going to close this project. And then, so for me, it looks kind of like this. So if you guys already have Pycharm, what you want to do is you want to open it up. And then as soon as you open it up, you'll get this window, just like you see me right now shaking around. You'll see a window just like this. And you'll be able to, over here on the bottom, click on Configure. And the very last option is check for updates. So if you have Pycharm installed already, you can check for updates, and then of course, update it. So that way, me and the rest of you we're all on the same version, and so it's going to be easy for us to follow along. So I'm updating mine. You guys can go ahead, download, and install yours. For Macs, it's going to download a DMG. For Windows, it's going to download an exe, but the process is the same. Just download it and then follow the prompts. I'm going to see if there's any questions. Yeah, I think 8 gigs should be fine. I don't think I use more than 2 for any of this. Your biggest problem with RAM may be when you run a WebDriver, because what happens is it pops up on browser windows. And so if you're doing, this webinar, so you're running one application that's showing you video, and then the browser is opening up and showing you videos, and Python is running, and then Pycharm is open, that might be the problem. But Pycharm by itself, you don't need a lot of RAM at all. So that should be fine. And if you do end up having problems in the future, then we'll cross that bridge when we get there. So yeah, don't worry about it. We will be using Git. Yes, I'm glad you asked me that. So I'm going to create a Git repository for you guys so I can share my code with you. I don't know if that's going to happen today. I think today is more of a preview, and I'm certainly happy to upload code from today into Git so you guys can view it and download it. But there's just a lot of stuff to cover today. But yes, absolutely. I'm more than happy to do that. They're just meant for different things. So Visual Studio is essentially for Visual Basic, and I believe C++, right, or C really. I haven't used Visual Studio in a long time. Pycharm is specifically for Python, so it's more or less for Python IDE. I like it because it's very snappy. You can also use Eclipse. You can also use Sublime. There's a lot of different IDEs. If you already have a favorite IDE, meaning you already know Python, you've been using an IDE, and you're very attached to it, I'm more than happy with you continuing to use your other IDE. The problem is that I won't be able to help you if you run into a problem, not code-wise, but IDE-wise. So if you need to install some kind of Python package and you don't know how to do it on your IDE, I won't be able to help you. You would have to figure it out on your own. But if you want to use another IDE because you're very familiar with it, then I don't see a problem. You can, by all means, use whatever you feel like. So, okay, let's get, I guess, a show of hands. You guys know how to raise your hand on this thing. How many of you already have? No, let's do it this way. How many of you still need to wait to finish downloading Pycharm? So those of you who have Pycharm, I don't need to see your hands. Just the ones that still, I need to wait to have you guys finish downloading Pycharm. Those of you who joined late, we're downloading Pycharm. So we basically went into any browser. It doesn't matter which one. And we're downloading Pycharm, right? So Pycharm, we're downloading Pycharm. And then we clicked on this link and we chose the black button, all right? The black button is what we want. That's the one that's free. We don't want the blue one. That ends after 30 days and we have to uninstall. So black button is what we want. And those of you who have Pycharm, I asked everybody to open up theirs and to update it. So again, if you open it up, on the bottom over here, there's configure, and you can say check for updates, and you can update it that way. Are you asking about Python in terms of to take this class, or are you asking in general for for a career? Like in your career, how much Python should I know? Versus for this class, how much Python do I know? Do I need to know? Which one are you asking? In general, I would say well, first of all, it depends on which salary you want to have. The more Python you know, the higher your salary. Just like developers, automation QA have multiple levels, and the higher up you go, the obviously the more you're valued and the more you get paid. But I think at the very bottom level, you should have at least 2 college level courses of Python. So I hope that's a good way to answer it. So slightly more than basic. I would say like introduction and then medium, right? I wouldn't go for like all of this advanced stuff. I wouldn't go for like architect kind of level, but at least 2 college levels of Python I would seriously recommend. Python is very easy to pick up. It's very intuitive, so you don't really need to take it in college. I'm just using that to kind of give you a good understanding. You can totally do it by yourself or online, all tutorials and everything. Yes, absolutely. So I think that's important to kind of point out that this class by itself aims to cover a lot of material. So it's not just Python, right? This is not a Python only class. This is an automation class. So if you want to learn Python, I would really, really encourage you to study on your own, in your own free time. At the very least, do the homeworks that I assign, And at the very least, I would also maybe challenge yourself to kind of take it a step further, right? If I assign like something, basic, think to yourself, okay, well, how can I make it more complicated? How can I do more? I find that people who do that usually are a lot more successful long-term, both in this class and career-wise. So challenge yourselves. Okay, so hopefully at this point, everybody was able to download Pycharm and they double-clicked on their executable and they were able to install it. So after you finished installing it, it should pop up. It should look something like this, okay? Now, we're going to kind of leave it like that for a second because we also need to make sure that we have Python installed, all right? If you don't have Python installed, you can always do it later after you create your project, but it's probably easier for everybody to do it now. So here's what we're going to do. If you're on the Windows, I'm going to need you to open CMD. Now, on the Windows, on the bottom, you should either have a search icon or you can just click on the window icon and start typing. The search was just going to automatically open up for you. For a Mac, right, you can open up this top icon over here on top. And again, you can just search. So here's what I want you to search for. On the Windows, search for CMD, right, command prompt. And on a Mac, I want you to search for terminal, okay? Just like that. It's going to be this black kind of icon with a caret on it. So once you find it, just press enter. It's going to open up. Oops, sorry. This is left over from my previous one. So once it opens up, it should look something like this. Now, when I open up mine, people ask me, why does it say behave here? This is just left over from a BDD framework that I used a long time ago, and it just gets enabled by default, and I haven't disabled it yet because it doesn't really bother me. But yours should just be a $, or it should be your path, your home path, and then $. So yeah, you can just ignore this for me. So once you have your terminal open up, or once you have your CMD open up, the actions are completely the same. You are going to type in Python, all right? Python. And then space. Here, let me make this a little bit bigger so that it's visible to everybody. Whoops. There we go. You guys see that? Well, hopefully, yeah. So you're going to type in Python and then space -- version. Okay, that's what you're going to type in. And one of two things is going to happen, all right? You're either going to get back something, and yours might say Python 3.8, or yours might say Python 3.6, or yours might say Python 2.7. Doesn't matter. It will say Python something. Or second thing that might happen is you might get something like this. I'm going to mistype it so that you guys can see. You will get something like this. It will say command not found, okay? So if you get back a command not found, it means you have no Python at all, like no Python. That means you have to install it, which is, again, not a big deal. We're going to do it right now together. If yours comes back saying Python and this first number right here is not a 3, all right? So we want it to be a 3. If you see it and it comes back and it's anything but a 3, like a 2, or God forbid a 1, then you need to get a later version of Python. Okay, so you need to upgrade your Python. Now on a Mac, it's perfectly fine to have multiple versions of Python. So I actually have multiple versions, and my system Python is 2.7, but I actually already have 3.8 also installed. Same on the Windows. You can have multiple versions of Python. So if you already know that you have a good version, a Python 3, 3 something, then you don't have to do the next step. But if you don't know, then probably it means you only have one Python installed or no Python installed at all, in which case you want to do the next step. So here we go, the next step. The next step is we're going to go back to our browser, again, any browser, it doesn't matter which one, and we're going to do, we're going to search for Python, just Python. And again, well, I guess this time around we don't get too lucky. There's an ad, but If you scroll down, you should see python.org. All right, python.org, and right under it, there's a download section. Yep, 3.8 is beautiful. So you're gonna get this download section. You're gonna go there. And then here, you actually do want to click on the button that's inviting you to click on it. So the big yellow button is your friend. You do want to click on the big yellow button. So go ahead and click on that, and that will download Python for you. I already have Python installed, so I'm kind of questioning whether I should install it or not. But okay, I'll do it just, so I know your experience. All right, so there you go. It's finished downloading. You just double click on it. And it's going to take you through the wizard. So you're just going to do continue, 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 agree, continue. Now, when you reach the installation type, you can either say install, or you can customize what you want to install. If you know what you're doing, then you can change these. Actually, most of these are actually good. I don't know if you need GUI applications, but it's small enough that I wouldn't really worry too much about it. Like, it's tiny, it's less than half a meg. So I would just keep all of these. So there we go. You just say install, and you will have Python installed. You will probably need to enter your admin password though. So hopefully you know your admin password, and then that will install your Python for you. Yes, 385 is beautiful. Anything 3 is good. You just want to make sure it's not too simple, because anything that is any version 2 Python is getting deprecated. It's basically not being supported anymore. So we want to get 3 or greater. 3.6, 3.7, 3.8. All beautiful, all good. Same for Windows. What do you mean, what about Windows? Same thing. So go to this download, and it's when you get to this, because you're getting to it from a Windows, you will actually get a download button for Windows. This is also our site. So when I got here, it actually knows that I'm on a Mac. That's why it's offering me this button. If you go to this exact same URL on your Windows, it will actually offer you a button to download for Windows. So you just bravely click on it, and you don't have to worry about it. So same process. Click on it, wait for it to download, double click the exe, and then just install it. You're quite welcome. Okay, once you are done, you can close your installer. Hold on, you guys, I'm just going to close all of my installers. So there you go. After that, you don't really need to do anything else. You can close both of your tabs. You have your Pycharm, you have your Python. You don't really need anything else. That's it. So after that, go back to your Python, or I'm sorry, go back to your Pycharm. And what you're going to do is you're going to click on this button right here. It says create new project. Now, as you can see from me, I have a lot of projects already here on my left side, but that's because I use my Pycharm all the time. And it stores, this is the most recent list. So it stores all of my most recent stuff here. But for you guys, this might actually be clean, or you might have 1 or 2 things, right, from previous classes. So don't worry about what you see on the left side. That's going to be different for all of us. This is the section you want to be concerned with, okay? So right now, we're going to click here. It's going to say create new project. Now, if you ever download my code, all right, if you download my code, then you will actually want to use the open option, and then just browse to the folder you download from me, and it will create a project that way. But right now, for today, we're going to do create new project, and we're going to go through the wizard. Okay, so here we specify a location. Now, if you're on the Windows, yours will probably be along the lines of C:// and then I'm sorry, not // C:// and then your folders, your folder structure. For me, I'm on a Mac, that's why it starts with / first. But here at the very end is where we specify two things. It's actually one location, but two things. Here we specify the name of our project and also the name of the folder that's going to contain our project. So make sure that you give this a name. Don't leave it as untitled. It's just, I mean, you could, but it's not a very good name for your project. So, you can call it Python automation. You can call it anything really. I don't know, can't come up with other names, but I'm gonna call it automation class, and then I'm gonna do, no, let's do something smaller, automation 2020, and then maybe we'll call it summer. But you guys can give it a shorter name. I really have a lot of things. So that's number one. Make sure you give it a nice name. All right, that's important. And number two, there's this little triangle right here. Okay, it's kind of hidden. So you're going to click on this little drop down. For you, it might look like a plus sign. For some people, it looks like a plus sign. But in any case, you want to unfold this thing. And for some people, it might just say project interpreter. So there's no Python 3.8 afterwards. It just says project interpreter. And this whole section is empty. Okay, so for you, this might be completely empty. So what you want to do is you want to click on this drop down, and then you want to select an interpreter. All right. You have two options. The first option is to create a new virtual environment. And what does that mean? It means that right now when you installed Python, it got installed into your system folder. But if you don't want to continue using Python from the system folder, this first option allows you to create a mini copy. So your Python core will still be in your system, but your mini copy will serve as storage for any additional packages that we will install. So as you might imagine, Python comes with a limited set of functionality. Any third-party functionality needs to be installed separately, and this option will control where it gets installed into your system, which means that every other project will also share those same packages, or into this one location, special just for this project that you're going to be using. So up to you. I don't like to use this first option because it stores it in the same folder as the project. And so it's just more difficult for me than to share files with you guys when I zip them up. But for those of you who are at home and you're not planning to share your files with other people, you can absolutely 100% use this option if you wish, okay, if it makes it easier for you to clean up later. So I'm going to use the second one, which is existing interpreter. This means it's going to use the Python that's currently installed in my system folder. So as you guys can see, I have multiple installed. So I have these 3.8, 3.7. I have a couple 2.7s. There's lots of Pythons. So I'm just going to choose this one, the 3.8, because it's the most recent. And then I'm going to click create. Now, some of you might be raising your hand right now, not yet, but maybe in a little bit. And you will be telling me, Ellie, I have nothing here. There's nothing in my field here. There's nothing in my field here, right? There's nothing listed. If that's the case, if you opened up this, drop down and you don't have anything listed under existing interpreter, go ahead and click on this dot button over here. And then you would need to click on system. See, there's 4 options: virtual, I don't even know what conda is, system, and pip environment. You want this one that says system, and then you'll be able to select it from here. So you should be able to select it from there then, okay? And so you can select like Python 3 or, Python, whatever you have. Now,
If even then, even if you get here, there's nothing here, that sometimes happens, very rarely, there's again that the triple dot button. So if you click on that, you will actually be able to browse your your system folders, and then you should just be able to find your Python that you just installed and attach it that way. So that's another possible way to do it. Especially if you're in the Windows, if for whatever crazy reason it's not showing up anywhere, go here and just browse to your program files. Usually when you install Python, it gets installed into one of your program files folders or C drive. So basically just find it and then click on it, and you'll be able to use it. It will show up here, and then you can select it and say okay. So that's all the different options you have, but do make sure you select at least one Python interpreter. You're going to need it for your project in order to run your code. So, all right, hopefully that made sense to everybody. If you have questions, put them in the the questions section, or once I have break around 9 o'clock Pacific, I will actually stay on, so you guys can take a break, but I will stay on, and you guys can unmute yourself and ask me questions, and I will be able to help you figure out how to fix it. So anyways, I'm clicking the create button. A little bit of magic happens. It's going to close open, so don't worry about that. You did everything right. Just getting all the files set up. Perfect. Okay. I don't know. I think that's a question for Michael. I do know that I am recording this class. So first, answer to your first half of the question. This class is being recorded. So there is a recording. Now, how Michael is going to share it with you guys, I do not know. But I'm absolutely, after this class is done, upload the recording of this class into his video library. So just, reach out to him tomorrow, and yeah, and he should have it for you. My webinar is telling me my computer is slow, so hopefully you guys don't mind if I turn off my webcam. It's going to make this better quality class. If you want to see my shiny smiley face again, then just let me know. But for now, I'm going to turn it off for a bit. Okay, so here we go. This is what you should have when your new project opens up. You will have essentially, a folder with nothing inside it. And then you will have one called external libraries, which is basically your Python. And then you will have your scratches and consoles, and you don't have to worry about that one either. So this is your Pycharm. This is what it looks like the first time you create a project. And the very first thing we want to do, the very first one, is we want to create some folder structures. So go ahead and click on the very topmost folder. And there's two things you could do. You could either right click and say new, or you can go to file and say new, whichever is more comfortable for you. But you want to click on the very top folder, and then you are able to choose what is this new thing that you want to create. So right now we're just going to create a Python package, right? We're going to create a simple Python package, and we're going to call it tests, because every automation QA needs a Python package called tests. And we're also going to create another new thing, and this time it's going to be a directory. All right, so we're creating Python package and directory. And this directory we're going to call, what should we call it? Let's call it, let's call it browsers. In the future, we'll be able to use it to store our browser executables. For now, it's just going to be empty. Okay, so here's why I had you do this. I want you to, using kind of your own, eyes, figure out what is the difference between a folder and a package, all right? Because they look pretty identical to me, all right? You have your folder, you have your package. So just experimentation-wise, what do you think is the difference between a package and a folder? Oh, thank you for letting me know. I'm going to plug in. There you go, problem fixed. We're going to try to touch everything. I'm being asked if this class will include UI automation and API automation. Yes. So yes to both. That's why this class is longer than usual. Instead of being 40 hours, it's 60 hours, because we do want to be able to do all of it. We want to be able to include API automation and WebDriver automation as well. So yeah, if you just, write me a message and tell me that you need me to pause for a little bit so you can catch up, that's absolutely fine. I will pause and wait. Dennis, you said something is different for you. What is different for you? Okay, yes. So I asked, what do you guys see as the difference, the main difference between a folder and a package? And some of you answered that there's a py file inside. Absolutely. So that's the important distinction. A folder becomes a package as soon as you create __init __.py file inside it. Now, if you double click on it, right, and you look inside, it's empty. It's just an empty file. So some of you might say, well, why do we need it, right? Why do we need this weirdly named empty file? But it's actually, it has two purposes. The number one purpose is this is how Python figures out which folders it needs to process and which ones it shouldn't, it can ignore, essentially. So if it sees a folder and inside that folder there is this __init file, then it knows that that folder has more Python for it to consume. But if it looks inside a folder and there's no init file inside, it knows it's just a simple basic, your system folder. And so it just basically ignores it. So even if you go ahead and put Python files inside this folder, when you try to import them into other files or you try to execute them from the command line, it's not going to be able to run them for you. So if you are going to be putting Python code into a folder, you do want to make sure it's a package. And you make a folder into a package by putting an empty __init __.py file inside it. Now, it doesn't have to be empty. The second purpose of this file is actually kind of a prerequisites file. So before any of the code inside this folder are going to get executed, this file is going to get interpreted by Python. So it's going to read this file first. So if there's any kind of passwords or special, data that needs to be retrieved before you even run your tests, or environment variables that need to be checked, or anything that's a prerequisite for your test to run that needs to happen, you can put that code here. You can put any of that stuff here, and it will read it first. So you won't have to spin up resources and do all of the other things if the condition isn't met. So two purposes, right? One is just, hey, this is for me, this is not for me. And the second one is, oh, well, not only is this for me, but I also have to do all these other things before I'm able to interact with the other py files inside. Yes, so let's talk about that. I'm being asked if an init file is the same as a class file in Java. So here, let me show again. Sorry, you guys. Let me do this. I'm gonna once again show how I created a folder and a package. and then I'll go over different Python structures. Okay, so two ways to create a file or a package, right? Because now you guys all know it's the same thing, except one has stuff inside, one doesn't have stuff inside. So two ways to do it. But I think the easiest one is if you just right-click on the location where you want to create your folder / package, and then you right-click, all right? Then you have the option to say New, and you are able to select the option you want. So Python or directory. Those are the two options we used so far. So directory or package, Python package. Or I know for some folks, it's harder to right click. So if that's, if it's difficult for you to right click, then, for accessibility reasons, then there's also file and new ... this option right here. Now, depends on which computer you're on, which operating system, there might be also a shortcut for you. So for me, for example, I can do Command N to open up that same menu. For Windows, you would have to look up what your shortcut is, but there is a shortcut also. So if you want to use a shortcut, that's fine. But I usually just do right click and I say New, and then I create whichever option I need to get that done. So. Okay, differences between, or what is an init file? If you're coming from a Java background, think of this more like a constructor, okay? But in Python, code cannot exist outside of a class, all right? So in Java. In Java, code cannot exist outside of the class, all right? So in Java, if there's a file, inside it, there has to be a class. And they have to have exactly the same name. And then the constructor is inside the class. And then all the other code is inside that class. In Python, there is no relationship like that. One file can have multiple classes inside it. One file can have Python code with no classes inside it. One file can have a certain name, and the class inside it can have a completely different name. So there's no connection between code, classes, and files. So Python is very loosey-goosey that way. Java is very, very strict about its rules. So, but the closest way to describe an init is constructor. However, in this case, this is a constructor for the package. You can also have a constructor for the module, and you can also have a constructor for a class. So in Python, there's multiple levels of constructors, and they're always called init, but it just depends on which level of the code you put them into. And then that way, it's not chaos. It's actually very custom. It's very customizable. So just to let you know a little bit of my background, I actually originally got my degree using Java. So I started with a Java background. And don't get me wrong, I loved Java. I thought Java was just the bee's knees, and I used it for a very long time. But then when I had an opportunity to switch to Python and really learned it and got to use it for automation, right? Not for development, but for automation, for test automation, Python really is a lot more fun to use. Okay, it's a lot more fun to write tests using Python than using Java. Now, if you're a developer and you're developing an application and you need it to be secure, then yes, Java is it, right? It's the thing. It's awesome. I'm all for it because of how strict it is. But for tests, we don't have to worry about security. So for tests, it's a lot faster to write tests using Python rather than Java. So I'm sure once you get to know it, you'll love it. There's also some things you can do in Python that you cannot do in Java. One of these is there's two commands, one called eval and one is called exec, and it actually converts strings into code. So you can actually build a string based on multiple, parameters or user inputs or whatever, and then actually execute it as Python code, which you absolutely cannot do in Java. In Java, you would have to have a switch or an if statement to, consider all the options. And here you can actually essentially do that same whole thing in one line instead of having like 20 different options, 20 if-else statements or switch statements. So very powerful.
Okay, let's get started. I'm sure all of you are itching to try out Python. Now that we have our project more or less kind of, ready for us, let's try to play around with Python a little bit. Let's get to know Python so we can see how easy and simple it is to write code. On the very bottom of your Pycharm IDE, you should have this panel. It's a small little panel, and on it you should have a few options, all right? So you should have an option called Terminal, and you should have an option called Python Console, all right? So the one we're looking for is Python Console. If you do not have a Python Console on the bottom, then there's this, like in the very, very left corner on the bottom, there's an icon. You don't have to click it. You can just hover over it, and then you should be able to find Python Console option there. So if you don't see it on the bottom, like I have it right here, right, then you can go ahead and find it at the very bottom left corner, and then you can just select Python Console that way. But as soon as you select it, you're going to get an extra kind of, I guess, window view, extra view that's going to pop up. And that's essentially a kind of interactive Python console where you can write your Python code and it will automatically execute it for you. So, cool thing. I'll be honest, I use this almost every single day when I write automation. I have, okay, maybe I don't have a horrible memory, but there's a lot of things to remember. And so when I'm not sure about some code that I'm writing and I want to test it out, this is how I do it. So I'll be writing my test here, and then instead of having to write, run my entire code so I can test out one line to make sure that my thinking, my logic is working correctly, what I usually do is I pop open Python console right here immediately in IDE, and I'll write that same line of code here, and it will show me the results. So I can immediately see, hey, yeah, okay, this is working fine, and my logic is sound, or it's going to give me an error, and I'm going to be like, oh, okay, I'm forgetting something. So you actually also see me do this a lot during class. During class, I'll be like, oh, I don't remember how this works. Let me pop open Python console and try it out. So you'll see me do it a lot. This is a very, very good tool. So I'm stretching this up really, really high because I want you guys to see what I'm typing. Let me also try to see if I can make it bigger. So there you go. We're going to cover the data types. There's a lot. Yes, it is like a sandbox. This is a good way to refer to it. Absolutely. Yes, sandbox to run the code. Now, there's actually also another way while you're debugging to also use it like a debugger as a sandbox, but I'll show you guys that later. For now, this is what we're going to use to play for a little bit. Okay. I'm going to see if I can maybe make this a little bit so I don't want to close my, I don't want to close this panel because I still want to see your guys' questions. So I'm going to do it this way so you guys can see this as well. This is a pretty important little panel as well. Okay, so let's try something simple. The very first thing we learn in programming, if you're not a programmer yet, is we learn what a variable is. All right, that's a very important concept. What is a variable? And the best way that I like to think about it is it's a container. Okay, it's a magical container. It's a container that can contain anything. So that's a little bit hard to imagine, but think of it like a Santa's bag, right? It's magical. Santa's bag can fit all the toys of all the kids in the world. So this is kind of like that. All right, so this is a special, like a way to store any kind of object. You can store things from a single number to an elephant, right? An elephant would be an object, or a house. You can actually store an object that has other objects stored inside it. So we're talking huge, huge, huge entities being stored into a variable, or small, very small ones, like a single character or a number. All right, so how do you create a container? Well, in Python, it's very easy. All you have to do is name it and then put some stuff inside it. Okay, so first you need to figure out what do you want to put inside it. All right, so if you want to put a number or if you want to put a string. So think of about what you want to store. And then once you think of what it is you want to store, you want to come up with a name for it. So for example, I'm going to store right now my name, my full name. And so because I'm storing my full name, probably it makes a good sense to call my container full name. All right, so containers are all, let's think of them as Tupperware in your refrigerator, but it's not see-through, okay? They're opaque. So we don't know what's inside. And the only way for us to tell what's inside is by the name.
So if you call containers things like A, B, J, Z, Y, not very self-explanatory. You don't know what's being stored inside, right? You might open it up a Z container and yes, or you can do hello world. You might open up a Z container and oh my god, there's like I don't know, Loch Ness monster in there, right? So you probably want to name things like this so people know what to expect. So here we go. I'm going to give it a name, full_name. That's what I'm going to store inside. Now, there's really very few rules in terms of how to name things in Python. Really, we only follow, I guess, 3 rules. It has to start with a character, all right? So it can't start with a number. And if you want this variable to be publicly available to everybody, it cannot start with an underscore, all right? It has to start with a character, and so like a letter, okay, a letter. And it can't start with an underscore if you want it to be publicly available. If you want it to be protected and hidden and you don't want anybody to see it, then you put an underscore in front of it. But in this case, I want everybody to see it, so I'm going to call it full name. And also, you can't have spaces, all right? So can't have spaces. If you want your variable to be called 2 words, then put an underscore between them, and that way, you have your 2 words. So full name, and then you're going to put an equal sign, just a single equal sign, and whatever you want to store inside it. So if I just put a number, for example, 4, I don't have to put double quotes around it, okay? Python will automatically interpret that, ooh, there's no double quotes, so it's a number, so this variable is going to store a number. But if I'm storing anything that is a combination of characters or letters, I do have to put quotes around it. And it doesn't have to be double. It can be single. Python doesn't care. So if you have a preference for single quotes, then use single quotes. If you have a preference for double quotes, do double quotes. You'll find while taking my class that I use this and that. I interchange them. So yeah, don't be surprised, and the type of quotes don't matter. So here we go. I'm going to put my full name, and I'm going to press enter. Now, 2 things happen, all right? First of all, you got a new prompt, new clean prompt here, but also on the right side, you got this new entry, right? And so what this is it's a log of all the things that you've currently created that are currently being stored in memory. So as our Python is running, it's storing things in memory. And one of the things we currently created is a variable called full name that's inside it stores a string, right? So basically anything that is a combination of letters is a string. So this string, and the value of that variable is Ellie, and you guys can't see it, but it's actually showing my whole full name. So Ellie Yampolskaya, right? So there we go. I created a variable, and you guys can see that variable is being stored in memory. Now, let's also try to create another variable, and let's call it age. Now, ladies, you are under no obligation to put your true age. Neither am I. So I'm going to say that I'm 21 for the nth time, and I'm going to say enter. And as you can see, as soon as I said enter, it created one more variable right here, age. But this time, Python automatically figured out that, ooh, this is kind of nice. Yeah, it's an int. So you could use actually caps. We'll actually talk about caps later. So automatically it was like, oh, it's a number. There's no quotes around it, so that must be an int. And an int is just a code way to say that something is a whole number. So when you see a whole number, whether it's positive or negative, it's an int. Now, what happens if I store a decimal? Let's say something like what could be a decimal? Let's do balance, right? Ooh, balance. And we're gonna say, I don't know, $71.33, right? So if you do that, again, Python automatically goes, ooh, it's a decimal. And so the Python way of saying decimal is to say float. So this is probably, I think, the coolest thing about Python. The coolest thing about Python is that it automatically figures out what it is you're trying to store, and it creates a variable to store that data without you having to specifically explain to Python that this is what I want to store, okay? Now, if you really want to make sure, like if you really want, in Python, there is no way to force somebody to store a specific type of data. So in Java, there is. So in Java, you can say, I want this to be a string and nothing else. And then if somebody tries to put a number inside it, it's going to go, oh, I'm not happy. In Python, no. In Python, you can suggest gently, nicely. Be like, so, by the way, it would really be nice if you put a string inside here. And you could do this. But if somebody maliciously wants to put, I don't know, a decimal inside, they will still be able to do it. So here's how you can suggest things, okay? So for example, you can say things like, I'm running out of ideas here. Let's do height, right? You can do height, and then you can do things like, guys, I'm like blanking out right now. It like this. You know what? I'm blanking out on how to suggest things right now. Literally did it earlier today, and now I'm blanking out. Okay, you know what? I'll go and break, and I'll look at my cheat sheet. But there's a way to gently suggest it. As you guys can see, I don't do it very often in terms of variables. Mostly I do it for functions and for return values. But so sorry, I'll show it later. But anyways, so Python is very forgiving. Even when you imply that something needs to be done, it's people can pretty much do whatever they want. Okay, let's keep going. So we now have 3 variables. We have 3 different types of variables. We have age, balance, full name, and then what can we do with them, right? So what can we do with them? Well, each one of these variables, because Python was automatically able to figure out, oh, I know what it is, now comes with certain other additional things you can perform on it. So functions you can perform on it. So let's try the first one. Let's do something like age, and then after it, we're going to put a dot. Let's see if it's actually going to work for us. All right. So if you say a dot and you wait a few seconds, you're going to get a list of options that's going to kind of, show up for you automatically. And as you guys can see, some of them have little m next to it. So m stands for method. Sometimes you'll see things that are f. Sometimes you see things that say p. So p means property, which essentially is kind of like a method, but not really. It's a variable that you cannot reassign, and the way to declare a property is by declaring a property method. I'll show you guys later in class, maybe towards the end of the class, how to do it. But so some of them will say p, which is a property. Some of them will say m, which is a method. Some of them might say that f, which is a function. And then some of them might say c, which is a class. All right. So that's one thing you will notice. The second thing you might notice is that some of them start with underscores, right? And some of them do not. Now, the things that start with underscores, those are special Python pre-configured, pre-built, reserved functionalities. One of them we already know, right? Init, we already met it earlier. But there's also some other ones as well. So, directory, equal, documentation, true or false. Let's see, what's another one that you might end up using? Well, some of them you probably recognize, things like round or reduce, or let's see, floor. I saw somewhere here floor, right? So if you do something like it's hard with an integer to come up with something. Let's do bit length, right? And you say enter. It will say that the bit length is 5, okay? And some of you are like, why 5? Well, think of it, it's binary, right? So how many bits does it take to represent 21? So if you write out 21 using binary, how many bits? So 5, right? Let's do another thing. Let's do the same thing for balance. So let's do balance. By the way, you'll see that I'll type in 2 or 3 letters, and then all of a sudden the rest of the word will just automatically, magically appear for me. So it's very easy to do. You can do control. You can press the control key and then space, and that will actually give you auto suggest for you whatever it has in memory for you to autocomplete. So that's why I don't actually type things out. They quickly appear for me because I autocomplete all the time. So here we go, balance, and then you're going to put a dot. And again, you have all these options, right? And you can ask, is balance an integer? Is it an integer? No, it's not, all right? It's not an integer. Or you can say things like, oops, excuse me, trigger finger, dot. Let's see, I want to see a hexadecimal version of it. So this is what it would look like as a hexadecimal, all right? If I was to convert it into hexadecimal. Or let's see, what else can we do to it? Let's try floor. No, maybe not floor. Let's do let's do round. All right, so let's do round. So there we go, we rounded, right? So it became a whole number by doing round. So again, a Python very quickly figures out options in Windows. Oh, okay. So I guess Shift tab, is that correct? So here we go. Let's try last one. Let's try full name dot, and then full name is actually a string, so that has probably the most things you can do on it, all right? And you're going to be working with strings a lot as part of your automation journey, so it's very good to kind of go through all of these options and know what they do, so that you can later use them. And we're going to play around with some of these. So I want to spend a little bit longer on this so we can actually write a little bit of code and then be able to use it later. So let's get familiar with some of these. One of them is called split, right? So you can actually split a long string. And again, by this point, you guys should remember that a string is just a combination of characters, right? You can split a long string into pieces, right? So pieces. And you do it by supplying a separator. So by default, the separator is a space, right? It's a space. So if I say split, and I do not put anything else in those parentheses that are going to appear, right? And if I just say enter, it's going to take that space that's inside my full name, right? I have that space right there, and it's going to use it as a point to cut my string into pieces. Now, I only have one space, so that means I'm going to get two pieces, right? One cut, two pieces. So on the left, I'm going to get my first name. On the right, I'm going to get my last name. And another thing you should observe is that when I split my string, right, the data type string, into pieces, what it gave back to me here in my Python console is this square brackets list. So it's a list of pieces, but it's surrounded in square brackets, right? So we actually, by doing that, created a list, all right? So we easily created a list. Now, right now, what I did is I took my variable, right? And when I said dot and I called split, I called a function on my variable. So my variable is a string, and because it's a string, there's a whole bunch of string functionality that we're able to perform on it. And as soon as I called it, right, it returned a list for me. So I called a function to return the list. But here's the thing. As you guys can see, my list did not get stored in memory, right? So I see it here in the console. It got output to the console, but it did not get stored. So if I wanted to store my list, how would I do that? Well, same as before, I would have to specify the name of the container, right? And then put an equal sign and then call my function after the equal sign. So this is what it would look like, all right? By the way, if you want to repeat your previous operation, the one you already performed, just press the up key, all right? So if you press the up key, it actually stores a history of everything you already written. So what you see right now is I'm going up, 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 down, 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 down. So there's a history of every command that you typed in today. And so if I press up once, it's the previous command. So here we go. That's my previous command. I'm going to go to the beginning and I'm going to call it name underscore list equals. Now I have a question for you guys. I called this name list. Did I have to call it that?
No.
Why not? Because it's just a name for the container. You don't have to call it anything. It's just, you can pull any name, right? I can call it J. This would work. Now, is that a good name? I don't think that's a good name. But, you know, it's just a name for your Tupperware. It's going to create a container for you.
For your understanding, right?
I'm sorry?
Just for your understanding, right?
Mm-hmm. Yeah.
So you're not confusing.
Exactly. It's just self-documenting code, right? So I think if there's anything else that I want you to walk away from this class, besides, of course, understanding a little bit of Python WebDriver and API automation, is how to write self-documenting code. The reality of things is when you start writing code for your job, you write so much of it that you're not going to be documenting every single line. You're not going to be leaving a comment on every single line and saying, well, this J contains this inside and this K contains this inside. So what we do is we rely on self-documenting code. What does that mean? It means that when we create a function, we call it whatever it does, all right? So whatever its purpose is, that's what we call it. When we ever create a variable, we call it what is going to be stored inside it. Whenever we, create a class, we call it whatever it represents, an object that it represents. So by calling things what they are or what they do, our code just reads like English, right? It reads like a book. We don't have to document it because, well, it's already documented just by, having named things correctly or logically. All right, so here we go. I'm going to say enter. And as you can see, it creates a list. See, right now it says I'm a list. And there's two things inside me. So again, Python was able to figure out what is going to get stored inside and created a container for it. So in fact, on your right side, you can unfold this thing and you can look inside it. And not only did it figure out that it's going to be a list, but it also figured out what each of the items inside the list is going to be. So you got two strings. All right. So it figured out a string and a string. All right. Let's try some other things. Let's do full name again. Again, I'm auto-completing, so I'm doing control space. It auto-completes the whole word for me. That's why I'm typing so quickly. And I'm going to say dot again. So as you can see, there's some other options. There's a lot of them. I'm going to the ones that I feel are going to be most useful for you to know. So another one is, let's see, where is it? Another one is title, okay? Title is another interesting one. Now, right now, title is actually not going to work for us because our name is already properly capitalized. So what I'm going to do right now is just bear with me. I'm going to break my name. Don't do this. I'm just going to show you. So something like okay, so gibberish, right? I'm going to do gibberish. As you guys can see, my full name got updated over here. But when I say full name dot title and I press enter, see, it looks nice again. You see that? Looks nice again. Now, what you have to realize, however, is that even though I said full name dot title and on the screen in my console, it looks nice again, as you guys can see in memory, it's still the same. In memory, it's still messed up. So my question to you, right? And you can put this in the chat or you can speak up. How can I, given bad data, so here we go, I have, okay, it's not bad, given incorrectly capitalized data, full name, how can I update it to be properly capitalized and actually keep the result? Okay, so I want what's right now in full name, all LE up and down, to be converted into this. Like I want to have it back to this. How can I do that? What do you think? So we know how to convert it into proper case, but my question is, how do I now get it to stick, to actually stay inside full name as proper good case? Who knows?
And we call a command for capitalization.
Oh, that's what we did, right? So there's a command, it's called .title, and it capitalized correctly my content inside that variable, but it didn't store it into the variable. It just kind of put it on the screen and it said, yes, 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 good, good. Some people are giving me the answer. So absolutely. So what happens is, and this is a little bit not intuitive for people with a math background rather than the coding background, is when people from math background see the equal sign, they're thinking, equality. They're thinking, left side has to equal right side. But in programming, an equal sign is actually just, it's a funnel, right? It's a pipe, and you're piping content into the container. So think of it as kind of like, you have a container and you have a little funnel and you're funneling stuff inside. So that's what an equal sign is. Think of it as like, right? It's going in there. If you actually want to compare the left side and the right side, you actually need two equal signs, and they're going to work like a scale, right? So if I wanted to check whether 4 equals 5, I would put two equal signs, and then of course I would get a false, all right? If I want to assign things, I use a single equal sign. And so the answer to the question I just asked is, I'm going to say full name equals, and now I'm going to repeat this entire command. So we already know that if we say full name.title, we're going to get that, whatever's inside full name to be properly capitalized. Then the next step is to store it back into the same container. So think of it this way. You have a container. You're going to take the data out. You're going to, massage it so it looks nice. And then you're going to put it back into the same container. So it's the same container. The container is going to get reused. So you're taking the data out, massaging it, putting it back into the container for, for whatever, for later. So here we go. Full name equals, and then we're going to say, oops, that didn't work. Sorry, you guys, one sec. I don't know why it's not working. Like that. So we're going to say full name equals full name.title. Now, if you look at this code, it might be a little bit like, I'm not sure I understand it. But if you think of it kind of like, all right, so I have a container called full name. There's stuff inside. I'm going to take that stuff out. I'm going to title, right, capitalize each word in that, of that data. And then I'm going to put it back into the container called full name, right? Then it makes sense. So that's what we're doing here. So if I press enter right now, as you can see, immediately full name got updated, and now it's all nice again, right? Nicely capitalized. So here we actually did two things in one. There's two things happening here. There is massaging of data and then storing it back into the same container. Okay, let's do something else. Let's do full name and then press another enter, or I'm sorry, press another dot. And we're going to use this find command, all right? Find command. Now, the find command is also the same as the, where is it? Index command, all right? So the find command and the index command are the same command, exactly the same. In fact, if you go and you look at the code of the find command, it calls the index command. So if you feel like using index instead, or they're interchangeable, they're completely the same. It's just, easier for people to remember find rather than index. So here we go. We're going to do find. And then this is the first time where we actually, instead of calling a function, we're also going to tell the function what it is we're trying to find, all right? So before that, we were always putting empty parentheses, empty. But now we're going to use these parentheses to actually pass in some inputs, some requirements into the function, all right? And the function is going to use those requirements, that input, to give us the desired output. This function will not work without providing input. You cannot find something without knowing what you're looking for. So here, we're going to specify what it is we're looking for. So in quotes, again, single or double is fine. Pick your, pick your flavor. We're going to specify what we're looking for. So what do you think we should look for this time around? Let's look for, let's look for a space, for example. All right, I'm going to say enter. Now, what it gives us back is a number. Let's think about it. What do you think this number represents? What is this 5? What does it mean? What do you think? It's not 5 spaces, right? We obviously don't have 5 spaces. We only have 1 space. So what does 5 mean?
Binary something?
Hmm?
It's binary number?
No, it's not binary, but close. You're thinking along the correct lines.
Maybe it's index.
Yes, index. So what does that mean? For people who don't have computer programming background, what is this index? How do you explain what an index is?
It's on which place the space is in the string.
Right.
And we start from null.
It's if you're going to start going from the beginning of the string and you start counting first letter, second letter, third letter, fourth letter, right? It's telling you which letter. This space, according to this, has location number 5. Well, then some of you are like, wait a second, it's not number 5, it's number 6. What is this 5? Ellie, you're lying to us. Well, that's because, unfortunately, in programming, we start counting not from 1, but from 0, all right? Because we're using binary to count, 0 is actually a number. So for us humans, 0 is actually absence of something. It's nothing. But for a computer, 0 is actually a completely valid number. It's a bit, right? It's a bit. So we start counting from 0. So that's why if you think along those lines, then it's 0, 1, 2, 3, 4, and spaces at location 5. So yeah, absolutely correct. 5 is the index of the space. In other words, it's the location of the space if you count from the beginning from 0. So let's do another. So let's go up, and now instead of space, let's put what should we put? Let's put E, lowercase e for me. You guys pick another letter for yourself. Just pick a letter that you have in your name. So here we go. Now I get 4, but I have 2 E's in my name. So why is it telling me 4? Shouldn't it say 0? Because, you know, my first letter of my first name is E. So, it's not telling me. It's not telling me 0. It's telling me 4. What happened?
It's lowercase.
Yeah, exactly. So what did we learn? We learned that Python is case sensitive. So a lowercase e is a very different character to Python than uppercase e. And if you think about it from the computer's perspective, to a computer, letters are just pictures. So a lowercase e is a very different picture than uppercase e, right? So computer doesn't think in letters. It's not like, oh, I understand, her name is Ellie. It's more of, oh, look at all those pictures. And so when you ask it to find a specific picture, that specific picture, lowercase e, has index of 4, all right? Now, let's do something that I have 2 of, or maybe even 3. I have 3 L's in my name. So I'm going to go ahead and look for an L. Now, look, let's before I press enter, in your mind, think, what do you think this is going to give us back, right? So I have 3 L's. I have 2 in my first name, and then I have 1 in my last name. What do you think when I press enter is going to happen, all right? What do you think? So, I hope you got a number now. I'm going to press enter. All right, so it gave me 1. Gave me 1. Now, the reason it gave me 1 is it's going to go from left to right. So it does it searching from left to right. And as soon as it finds the first occurrence, right, it gives you that index back, and then it's done. It's not going to keep looking. It's not going to be like, oh, well, you have one at index 1 and index 2 and then index whatever, right? It's just going to give you back the first occurrence of that letter. If you wanted to actually find the last occurrence, right, the last occurrence of that letter, there is a different function. Let's see if I can remember what it is. I think it's rfind. Yes, rfind. And it will be exactly the same thing, but it would actually look backwards. So it will start from the bottom, right, from the end, from the right. That's why it's R, from the right, and it will actually look towards the left. So in other words, this will be the first L it finds, so it will give you the index of the last L first, meaning 11. Hopefully that made sense. Now, why do I think this is such an important function to know? Oftentimes, when you are doing testing, you need to verify that a specific bigger result contains a smaller result. So for example, a welcome message, right? So maybe you logged into a website and it says, welcome, Joe. You know, we're happy to see you, right? And you don't care about the welcome part, and you don't care about the happy to see you part. You only care about the fact that it contains Joe inside, right? So how do you check using code that a string contains Joe? How do you check? Well, that's exactly how you would check, all right? You would actually grab the entire string, so the entire welcome message, and then you would say dot find, and you would look for Joe. So if Joe is found, it's going to give you back the index. Now, let's figure out what happens if Joe is not found. So I'm going to go ahead and press the up key, and I'm going to put something in here in my quotes that doesn't exist in my name. So I do not have a letter Z. And by the way, it doesn't have to be a single letter. It can be, multiple letters. So I can be something like Zoe, right? So I'm trying to see if my name contains Zoe. I'm going to say enter. And as you can see, it gives me -1, all right? So -1 means I didn't find it, right? It's a negative result. So it can give you any number from 0 to infinity, depending on how long your string is, if it finds the result. But if it doesn't find it, it's going to give you -1. That's how you can test. So just kind of remember that, and then later on when we do our test and we try to assert that a specific result is what we expected, and we need to check that a subset of it contains Joe, for example, then you will use the find command. Okay, let's do a couple more, and then we can move on to some more coding already in our Pycharm. A couple other interesting ones that I would recommend that you remember. Join. Join is a very good one. So join actually works backwards. So remember when we did split and it created a list, and so we had pieces stored in one container? Well, if you ever have pieces that you actually want to combine into a single string, you would use join. Now, it's a little bit counterintuitive how join works. You actually, instead of saying, specifying a list of things that you want to join, and then which character you want to use to join it, you do it backwards. So here, it's easier if I just show you. So remember, we have our name list, right? So we have our name list, right? So if I want to join it together, let's say I want to join it together with stars. I want to put star in between Ellie and my last name. So what I would do is I would say double quotes, or not double quotes, quotes, any quotes, and then a star and a quote, and I would say dot join, and then inside parentheses, I would put my list, all right? So then when I say enter, I will actually have a star joining items in my list. So again, items in my list are first name and last name, and by putting a star dot join, I specified that I want to use a star to join them together. And I mean, you can use any character. It doesn't have to be, this. You can put things like, I don't know, something like pretty, I don't know. You can do that, and then you will have, more things joining it. So another important one. Now, why this one you're not so much going to use in your testing, but when you go to interviews, a very common interview question is take a sentence, right, and rearrange the words in it backwards. So not the letters. They don't want the whole sentence backwards. They want the words in backwards order, right? And then join it together, right? So what they want is they want you to start out with something like, hello, my name is Ellie, right? And then what they want back is Ellie is name my hello, all right? So you start out with this, and what they want back is this. Does that make sense? All right, so that's a very common interview question. And actually, what I want us to do right now is I want us to pause for a second and do this interview question. At this point, we already know we have all the tools. Well, actually, no, there's one more tool we need. But let me show you that last tool, and then we will have all the tools to pass that interview question. So here we go. The last thing we want to know is how to switch the order, right? So how do we switch the order of items in a list? All right, and that's very also easy to do. There's two ways to do it, actually. There is one called reversed, and you just call it, and then in parentheses, you put your list that you want to, flip backwards. So in this case, name list. Okay, sorry. There we go, like that, right? So I had Ellie first, and then my last name second, and now I have my last name first and Ellie second, right? Makes sense, right? But I mean, look at it this way, right? When I called this code, when I called it, it switched the order, it switched it, but my original list is still intact. So the order got switched in a copy that got generated. And so because I didn't store it into a new variable, it just kind of flew out into space, right? If I actually want to switch the order in the existing list, right? So I actually want the order of things in this list to change. I would actually call it like this. I would say name underscore list, list, and then I would say dot, all right? And one of the options is reverse, right? Reverse. So you're going to say reverse. You don't put anything in parentheses. You just say enter. And when you look on your right side, as you can see, now my last name is first and my first name is second, right? So they flipped. So another common interview question, very common, is what is the difference between reversed and reverse? All right, so pay close attention. This one doesn't have a D. This one does have a D. So the answer to that interview question is twofold. There's two parts to the answer, and you need to make sure you include both. The first part is that one of them performs reversing of items in place. So that's what we saw here, okay? It actually reversed items inside the list itself. It didn't give anything back. It reversed in place. The other one, the one that has a D, it actually generated a copy of the list. And then in the copy, they got reversed. So one, they got reversed in place. The other one made a copy, reversed it in the copy. All right, so the original list is intact. So reversed original list is intact, and you get a copy of items in reverse order. And in the reverse without the D, things are reversed in place. And so your original list, the order of items in the original list is lost. Okay, that's number one part of the answer. Second part of the answer is one of these functions is a built-in function, and that's the one that has a D on it. That's a built-in Python function. You actually have to use the words built-in because it actually belongs to the Python built-in package. And the other one is actually a function on the list itself. So it actually belongs to the list object. So hopefully you guys can kind of understand what I was trying to explain. So when you go to an interview, you will probably be asked that question, or you may, not probably, you may be asked that question so you know the answer. The one with a D is built in, and it creates a copy and then reverses the order of things. The one that doesn't have a D on it, it belongs to the list and it reverses in place. Okay, so now that we know how to reverse orders of items in the list, we know how to take a string and turn it into a list, and we know how to take a list and turn it back into one whole string. Let's try to solve that interview question. Now, let's do a show of hands. I'm going to open up this thing. Let's do a show of hands. Who wants to try this on their own for 2 minutes? I'm going to give you guys. Oh, just one person is brave enough. All right, here's what I'm going to do. Let's do a break right now. All right, we're going to do a break. We're going to do a break for 15 minutes. So be back by 9:20 Pacific, right? And if you're on East Coast, then I'm sorry, but midnight. So 9:20 Pacific. And while we're taking a break, those of you who want to try it on their own, go ahead and try it, right? It's a pretty quick one. And then when I come back from break, I will show you the answer. We can do it together. Okay? Is that a deal for everybody? Okay. So break starts now. What I'm going to do during this break is for the first 10 minutes, I'm here if you guys need help. If you have questions, this is open floor. You guys can unmute yourself and ask questions. If you need help, I'm here to help you. But then I'm going to take the last 5 minutes to actually go and get some water myself. So go ahead. The floor is yours.
Ellie?
Oh my gosh, 6 a.m. Yes.
Sorry, quick question. So why why are you typing in the console, not in the? I'm just curious if you can, like, for instance, in IntelliJ or Eclipse, you're not typing in the console. You just print it in the console, right? I mean, you can type, but yeah, somewhere in there, you actually open the file
You're
or
asking me
class.
why am I not using this portion, the editor?
Yes, yes,
Absolutely
yes.
could. It's just it's right now when I'm showing things one line at a time, and I actually want you guys to
Okay.
have a history of stuff. It's easier for you all to learn this way. I absolutely could create a file and start typing stuff into a file, which is what we're going to do next, actually. But then I would have to run the entire code. So like each time, whole code. Each time, the whole code. So I would either need to comment out previous code, or you would have to, like, deal with all of that stuff showing up each time. So it becomes a little messy. That's all. It's just cleaner this way.
Okay, I just thought it's technically impossible. So, okay, sorry.
No. It's absolutely possible. We're going to do it right after break. So right after break, what we're actually going to do is we're going to open up a new file, and we're going to do our little interview question. So in the editor. So you're just like 5 minutes in front of me. So.
Thanks.
Ali, I probably missed that part. Are we going to cover any testing frameworks like PyTest or, I don't know, unit test or something like that?
So absolutely. We use, well, it depends on how we're going to use unit test or PyUnit. Now, PyTest is very similar. And the reason I prefer PyUnit, aka unit test, is you actually can run unit test using PyTest, but it's not backwards compatible. So you cannot run PyTest using unit test. You see what I'm saying? So, but basically every single test that we create in this class, we'll be using unit test for.
Okay, I got it. Thank you.
Mm-hmm. So in this class, I basically show you what I do at work every single day. Okay, fine. I'm lying a little bit because my actual job is a manager, but I'm a technical manager. So I actually do write code. I'm just not required to do it 8 hours a day. I get to go to a lot of meetings too. Very exciting, I'm sure. But my regular job is I am manager of software development in test. So in other words, I manage people who write automation. I also manage manual testers as well. But my core job, the reason I do what I do is I'm responsible for basically testing and automation. And I write code. So I'm showing you guys in class what kind of code we write. In fact, I literally will use examples. I won't show you my code from work because I will get fired for that, but I will literally use examples of how I would write code at work, how I have written code at work in this class. So how I create clients at work, how I create page objects at work.
Yep.
Victoria, your program is freezing. Which program? The ID? Victoria, speak to me. Okay, so probably it's frozen again. If you're what is it called? Go to what is this? Webinar. If your GoToWebinar is freezing, then you might want to what you actually would be able to do to lower your video. You'd probably want to close any kind of browsers you have, or basically close everything possible if your webinar is freezing. If your Pycharm is freezing, then try to collapse. You won't be able to see my face, but try to collapse your webinar to make it smaller, or to just completely collapse it down. That way your ID won't be freezing. But it's probably because you're just running too many applications simultaneously. So my first culprit would be, say, to close all the browsers. So we are done downloading. We're not using browser anymore. And whether you know it or not, your browser does eat up a lot of memory. So if you have your browser open, make sure you close it. You might actually want to go into Task Manager and kill all the windows first. And then
to make sure you kill all the processes for your browser. But yeah, we're kind of running a lot of stuff. So I don't know if you guys can hear it, but my laptop is actually making a lot of noise. So a lot of memory is being used. Thank you. New string goes, hello, my name is Olga. Yay! Now, Olga, I have a challenge for you. Now do it all in one line. Mwahahaha. In one line. That's fine. What I can do is let me open up this thing nice and big, and you guys you can see on my screen everything that we wrote. We really didn't write that much, so that's it. Your project you should still have. So everything you created in your project, like the folders, you should still have. What you lost in your console, yeah, you probably lost, but that's okay. I mean, it's not that much. So you have it on the screen. You can catch it. Ooh, that's a good question, Svetlana. How do you find the second, well, my second L, right? Hold on, let me actually experiment a second. I think there's a different function for it. Yeah, no, unfortunately not. Okay, so what you would have to do is, this is going to be a little ugly. You would actually have to find the first occurrence or the last occurrence, cut it off using either split or some other means, and then you would look for the next one. You can also do replacements. You can find the first occurrence, replace it with something, and then continue looking again. So, no pretty way to do it, unfortunately, but lots of creative ways to do it.
Ellie, sorry. Is there any way you can reverse it using the loop, for loop, for instance, or there is no way to do that?
Using the what? Sorry, I didn't hear the middle part.
For loop.
Oh, a for loop? You could, but why would you if you can do it all in one line using Python? So yes, I think if this interview question was given to you and you had to write code using Java, you would actually have to use a for loop.
Okay. You
would have to use a for loop. You see what I'm saying? But
yep.
The reason I'm giving you this is to actually show you the power of Python. In Java, there is no possible way, no matter how much you try, can you do it in one line. In Python, you can actually do this entire interview question in one line. In Java, it would take you, I think five lines. Anyways, more than one. Yes, Vlad, almost there. You just need to make sure you combine them. And then also, once you combine them, my challenge is to do it all in one line. Okay, so API and UI are two different things, right? API is essentially requests. It's the request that your UI makes in order to get data from the server. UI is the actual stuff you see with your eyes. So I think the answer to your question is yes, but they're not one thing. They're two different things. So we cover API and UI. I don't think we're going to have time to cover UI today. I'm going to really try, but so hopefully then we're going to do it on Monday. API, again, when I say cover, I don't mean all of it. That's what the 60 hours are for. But I'm going to kind of do a little intro, like, hey, here's how you would do something simple like this, and hey, here's how you would do something simple like that. So I'm going to talk today to you guys a little bit about API requests package, and then on Monday I can talk a little bit about WebDriver. And then if you guys decide to stay with the class going further, then obviously we would cover all the other requests possible, how to do sessions, persistent sessions, headers, cookies, how to deal with security tokens such as CSRF tokens. We're going to talk about different Python structures when we build out Python, our test frameworks. So we're going to talk about abstraction, inheritance, enums, just basically everything. Yeah, I don't know if that answered it or not, but WebDriver also, obviously, everything about WebDriver, weights, actions, XPath, CSS, whatever, everything. Can we do middle what? I want to know what middle stands for. Middle what? We didn't download any libraries yet. I just had everybody install Pycharm and Python. So you can totally catch up right now. We're actually going to be installing our very first package right after this break. So yeah. JSON and nope, no SQL database. No SQL database. JSON, yes, absolutely. There's really nothing to cover about JSON. JSON is essentially a combination of lists and dictionaries, which are both Python data structures, which we will cover. But a SQL database, no. That's a little bit outside of this class. If you still want to know about SQL databases, you can reach out to me separately and I can throw some code your way. But I don't have a live SQL database to use for this class. So,
Ali, could you please repeat the task? So we need to reverse this welcome message and like do it in one line?
No, my challenge was to do reverse, and some people gave me the answer. They gave me the answer pretty quickly. So I'm just being cheeky, and I'm like, hey, now do it in one line.
Oh.
If you can do it in multiple lines, that's great. But my challenge is if you can do it in multiple lines, now try to do it in one line. Middle L, I actually answered that. There is no easy way to do it, like using one line. You have to do one of two things. Find the first one, replace it with some other character and keep searching, or find the first one, cut it off, and keep searching. So, you guys, it's time for me to take that quick break. I'm going to be right back. Let me just go get a drink of water, and then we can have fun again. So I'll be back in just a few minutes.
I'm back. So a list is a collection? Yeah, but sorry. Yeah, so there's in Python there's different types of lists, collections. So there's sets, tuples, lists. I'm forgetting one more. So there's also dictionaries. They're not really lists. They're they have named values inside, versus lists have lists, tuples, and sets have integer values inside, or not integer, index values inside. So values are stored by index, versus in dictionary they're used. It's a key value, so there's a name attached to every single value. But yeah, more or less. Maps are dictionaries. So what in Python you would know as hash or a hash map, in Python is known as a dictionary. I don't know what a question mark means, but I agree. I wish there was like a way to delete these things quickly, but okay, you guys, let me just clean up so I remember which ones I already did and which ones I didn't. Okay, cool. So I think we're done to experimenting with console. Let me just quickly look at this list to kind of go through all of them so you guys know which ones are good. So title, split. Another one that we're going to end up using in this class is format. But I'll show you that later. It's more difficult to show it in the console than in actually real usage. So we're going to come back to format. Ends with, that's a Boolean. So if you want to check that a string ends with a specific character or substring, you would use that function. So for example, if I want to check that my last name ends with Aya, A-Y-A, I would say ends with, and I would put in quotes A-Y-A and would say true. If I put something like Z, it will put false. Capitalize will only capitalize the first letter of the string and then make everything else lowercase, versus title capitalizes the first letter of every word. That's the difference between capitalized and title. I'm not actually sure what, oh yes, I remember what center is. So center will actually pad your string from the left and from the right with whatever character you specify to the length that you want. So for example, if I want my first name and last name to actually be converted into a string that is 100 characters, and I want it to be padded by spaces on the left and on the right, I would actually say, 100 here, and I would put a space, and then we'll pad it. So like it will be like, I don't know, 40 something characters on the left, my name, and then 40 something characters on the right. Count. This is actually, here, I'll show you what that is. So this will actually count how many occurrences of a specific letter are in your name. Rather than finding where it is, it will tell you how many times it occurs. So that's what count is. Oops, excuse me, dot. Encode, this is for like URL encoding. Yes, absolutely. I'll show you how to do that in just a minute. Yes, I'll show you that as well. You mean like documentation instead of dictionary? Documentation? Yes, we do. I'll show you in a second. But anyways, everything that starts with is, that's over here, everything that's is, it's a question. So you're going to get an answer that's a yes or no, and we call that a Boolean. So if something is a yes or a no, it will return true or false, essentially. Index we already talked about. Join we are going to play around with right now. I actually forget what this one is, you guys. I would have to look it up. Lower is the opposite of title, so it makes everything lowercase. There's also another one that is called upper, which makes everything uppercase. Strip, there's actually a function called strip right here, strip. And else strip is the kind of sister of that. There's also R strip.
So what strip does is it actually cuts off any characters that are on the left or on the right. Most often we actually use strip to remove spaces around the string. So for example, you go to the web, you extract something from the web page, and it's space, space, hello world, and then exclamation mark, space, 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 space. So if you want to cut off those spaces in one go, you would use the strip command. So very, very popular one to use, the strip command. If you want to cut off everything, strip, it's not a regular expression. It's just, it actually uses a pretty dumb logic. It goes and looks at the first, at index 0 and says, are you a space? Then, it goes to the next index. Are you a space? It does the same thing from the back end. So from the tail end, are you a space? Cut it off. But or whatever character. I'm using a space because that's a default. But I mean, you can specify any character: stars, slashes, tabs, whatever. And the sisters L strip and R strip are just, it will be only from one side. So it will only strip characters from the left or only from the right, rather than stripping them from left and right. Swap case, I think is pretty self-explanatory. So if something is capital, it will become lowercase. If something is lowercase, it will become capital. I don't remember what zfill is, you guys. That might actually be new. Starts with is the opposite of ends with. It's a Boolean. You're asking a question. Does this string start with a specific other substring? Split lines. If you pulled out a paragraph and it has carriage returns, like new lines or slash ends, and then this will use the new line character to split your text. So every single specific line will be in a separate container, and you will have a list return. I think that's pretty much it. There's some other ones, but they're either new, so I'm not familiar with them, as in they were added after Python 3.5, so maybe 3.6, 7, or 8. I haven't read up on the new functions that were added, or I just haven't used them ever, so they're probably not that important. But anyways, that's what it is. Okay, let's go back now to our pre-break challenge. Okay, so here's what we're gonna do. Ooh, good job, Olga. You are very welcome. So here, I'm going to hide this for now so you guys can't see her solution. So anyways, in order to do our solution, we will actually need a Python file. So we now have a folder and we have a Python package, and we want to create a Python file. All right, so we're going to create our Python file inside our Python package. Otherwise, our interpreter can't interpret it. So go ahead and click on tests. We are going to right click and select new, and we're going to choose Python file. Okay, so again, right click on the tests folder, new Python file. I'm going to give you a couple seconds. And you will have a little, I don't know what to call it, mini wizard pop up. And we'll give you 3 options. So you can actually create a Python file, Python unit test, or Python stub. Python stub is just, it's kind of like a little piece. We will probably never, ever use it. So you will always select either Python file or Python unit test. Between you and I, a Python stub is actually still just a Python file. It's just going to have a different extension to let people know not to run it. That it's your notes, so to speak. So it's not actually an official Python thing. Okay, there's no such thing as Python stubs. It's just your IDE's thing. Your IDE gives you scratch paper, essentially. So Python stub is scratch paper. So for this class, we'll be either using Python file or Python unit test. So first thing we're going to do is we're going to give it a name. So we're going to give it, let's call it reverse. No, not reverse string, reverse order. You don't have to put PY, reverse order is fine. You can call it reverse order. And then because we are all automation QA, and that means we know that we need to write tests, right? We're going to use Python unit test. So we're going to select Python unit test, and then we're just going to step back. It's going to do magic for us. So when you say, I'm going to do it one more time for those of you who kind of missed it because it was too quick. I right-clicked on tests. I said new. I selected Python file. And then over here, provided a name, any name, file name. And then I selected Python unit test and pressed enter. Okay, so I just pressed the enter key and it created the file for me. So that's what happened. Okay. Start what with a C, sorry. Caps. No, it's not Java. So actually in Python, we call modules using a lowercase letter. The only thing that we use capitalization for is classes, which are actually inside files, and you can have multiple classes in one file. So yeah, files are usually lowercase. In fact, files are always lowercase. That's the professional way to do it, to call modules using a lowercase letter. And functions are always lowercase. Classes are uppercase and constants. So things that you don't want to change are usually uppercase, like all uppercase. So you will usually see properties be named uppercase, or you will see things that are constants that you want to call uppercase. But everything else, lowercase. Yep. Okay. What happened? Sorry, I'm going to delete this because I don't actually want to keep this thing. It was just to show you. Okay, so now you should have a file called reverse order. And inside it, you should already have some code. Okay, the beauty of using your IDE is that you'd already know some common things that most people always want to have when they're writing tests, and we'll put it there for you. So as you can see, it already imported the unit test package for you. So unit test is one of the many available frameworks for performing testing. Now, what is a framework? What is a test framework? A test framework is it's a incomplete application. The way I like to describe what it is to folks who are not coders is think of one of those PlayStations, those old ones that you used to have to like plug in a game into. Now everything is from the web, but it used to be that like even a PS, right? PS station. You used to buy your PS station, but then it doesn't actually do anything. You actually have to go out and get a game and put it inside, and then it works, it runs, it's great. Or we used to have those other like consoles where we took a game and we plugged it in and then we played it, right? But when you take it out, the actual console doesn't do anything. It's just it's a good paperweight until you put something inside it. So this is exactly the same kind of thing. So we have our unit test framework. It doesn't actually do anything. It doesn't run by itself. It doesn't do anything by itself. You actually need to plug in your test into it. But as soon as you write some of your own code inside it, right, it does a lot. So let's talk about some of the things that unit testing framework does for us, why we should use it, okay? So the most important thing it does for us is it collects results, all right? So it collects results, it gives us a nice result. At the end of our test run, it tells us what passed, what failed, how many things passed and failed. The next, well, I don't know if it's the next most important thing. The next cool thing it does, not in any specific order, is it knows in proper order, it will call specific functions to set up your test and to tear down your test. So in other words, get all the prerequisites ready and then clean up everything that needs to be cleaned up. Okay, so it will, it actually has multiple levels to set things up. It can set things up on test suite level. It can set things up on the test level. It can set things up on the overall entire, regression level. So multiple levels where it can set things up and tear down. There's also two different types of setup. It can do it per test, so every single time. Let's say that you have a test class that has 20 tests inside. So it will actually run a separate setup for every single one of those tests, and then we'll clean up every single one of those tests. Or maybe you have some kind of setup that you only need to run once. You don't want to run it for every single test because maybe it's a very expensive function. For example, getting a connection to the database. All right, that's a very expensive function. It takes time, out of your test suite. So you only want to do it once. So you can do it once per per class, or you can do it once per test, or you can do it once per suite. You have options essentially. And then same with cleanup. It also provides an entire list of ways to verify things. All right. Now in coding, when we verify things, we call it assert. Okay, the word is assert, and that's what you see here, right? The word assert. So right now, out of the get-go, immediately our IDE knew, it was like, oh, you're going to be writing a test. I know what to do. So it imported the unit test package for us. Okay, so there's this package called unit test. It comes with all the nice little bells and whistles. Then it instantiated a test class for us. Right, this is where we're going to be putting all of our tests. Now it gave it a pretty bland name. We want to change it probably, but it created a class for us, created a structure for us. And inside it, it also created our first test for us. Okay, so it did all the, I don't know if I want to call it heavy lifting, but all of the repetitive stuff for us. And then it also gave us a single example of how we can check that things are either working or performing or not performing. So first thing we're going to do is we are going to go ahead and put our mouse right after it says self dot. And we're going to do that same trick again that I used before when I was doing Python console. We're going to do control space. Okay, control space. Now, as soon as we do control space, it gives us a whole long, huge list of asserts, right? Asserts, and then if you scroll a little bit more down, a whole list of fails, right? So what did we learn? We learned, first of all, that we have all these ways to check that something is either true or false or equal or empty or not empty, or certain error occurred, didn't occur. Something is a dictionary, or something is a list, or something is more or equals to, less than equals to. So we have so many different ways to do it. All right, so many different ways. We can check that something is part of something else. We can I don't know what else. I already listed everything. We can look for a regular expression. We can check that something matches a regular expression or doesn't match a regular expression. So basically, what I'm saying is, go ahead, scroll, and quickly read through all of these options. What you will quickly realize is for every positive assert, there is also the opposite negative assert. So in other words, there's assert equal. But if you scroll a little bit down, there is assert not equal. Okay, so or for assert false, you will also be able to find assert true, right? Somewhere here in there. In there. I promise you it's in there. Assert less, there's going to be assert greater, right? Or assert less than equal, there's going to be greater equal. So both. So the idea is that you want to write code that is very easy to read. So if you're actually testing that something is false, you do not have to say assert not true. You can actually say assert false, and make it easy for non-coders to be able to read your code and figure out what your code does. So here we go. Let's go from the top. I already explained what this does. I think at this point you guys understand what a packages, probably. If you do not, and some of you were asking me, Ellie, is there a way for us to look up, all these things that, or to look up other packages, to look at code of the other packages? So you can, and let's do that right now. So if you're on the Mac, all right, if you're on the Mac, you want to hold down your command key. So that's the one with a little flower on it. And hold it down, and then you're going to point your mouse to anything. In this case, I'm going to use unit test as my guinea pig, right, to point to it. You see how it becomes a link? It's a link. So if I'm not holding it down, nothing happens. But if I hold it down, it becomes a link. So if you click on it, it actually takes you to that code. All right? It takes you to the entire implementation of that code. And you can do the same thing with functions. So for example, I'm going to hold it towards assert. I have my command being pressed right now. Press it, assert, and it takes me to that function. And that actually has documentation. All right? So there you go. Oops, sorry, my ID just froze. Hello. There we go. Sorry. Momentary hiccup on my computer. Okay, now if you're on the Windows, same thing, except instead of pressing Command, you're going to press Control key, right? So Control. So you're going to hold down your Control, and then you're going to do exactly the same thing. You're just going to, hover over something that interests you, and if it has documentation, you'll be able to see it, just like I do right now, right? See, it gives me documentation, kind of ish, or you can click on it, and it will actually tell you. You can see the implementation, you can see the code, and you can read the what it does. Okay, so let's do our interview, right? Let's do our interview. So during our interview, this is usually what happens. You come in and they say, look, sorry, one sec. They usually tell you, look, we want you to write code that takes a string. So you're gonna say, input, for example. Usually when I'm doing an interview, this is what I would do. I would say input. And you would say something like, what kind of input? I am, no, let's do some kind of sentence. Roses are red. And I am glad, right? There we go. And then what they want is they want you to reverse it. So you're going to immediately say expected result, right? Say expected result, and you are going to basically write what you expect your result to look like. So I would say something like, you know what, I'm going to remove this exclamation mark. That's going to be a little challenging. Glad am I, and then we're going to do red are roses. Okay, so far so good. I actually complicated it with punctuation, so I'm going to remove it for now. There is a way to take care of punctuations as well, but we're going to keep it simple. So this is what they're going to give me as an input, right? This is what I expect as an output. You guys see what I'm doing here? And then I'm also going to think to myself, I'm going to say, so what should I call my function that's going to be responsible for taking this input and reversing it? So what do you think? I'm taking suggestions right now. What do you think I should call my function, the one that's going to reverse this thing for me? There are annotations in JUnit, but not JUnit, first of all, PyUnit, but they actually have to be installed separately. They don't come with the unit test package. They actually come with a separate package. We can talk about that. I usually talk about that like later on in the class when we do data-driven testing, but maybe if I have time, I can talk about it next Monday. Okay, reverse string. Let's call it that. Good. So I'm going to say, all right, output equals reverse string, right? That's what I'm going to call my function. And then what am I going to feed into my function? What would I usually feed into my function? The input, right? The input. So I'm going to put my input into my function, not input. I don't know why I typed M. Sorry, mistype. So I'm going to put my input into the function, right? My function. I'm going to expect an output out of my function. I'm using the equal sign to store output from my function into a container that I'm also going to call output. Does that make sense? Hopefully it does. So during the interview, my interviewer said, here's your input. And then I am going to determine in my head what I want my expected result to be. And I'm going to ask my interviewer, I'm going to say, is this what you expect back? And the interviewer is going to say, yeah, that's what I expect back. And because I'm a QA, I'm not a developer, I'm immediately going to say, I'm going to need to test my stuff. So let me write a test. So that's what we're doing right now. We're creating a test. Now, we probably shouldn't call it test something. We'll pick a better name for it a little bit later. And then immediately I'm going to think of a name for this function that I'm going to write, that my interviewer is asking me to write. I'm going to call it reverse string. and I'm going to create an assert. So now that I have my expected result and I have my output, right, or I will have my output later, I'm immediately going to say self.assert. And in this case, I'm comparing my output against my expected result, right? So I'm comparing to see, did my function, the one I wrote, really generate the output that I expected it to generate, right? Even though I haven't written the function yet. This is what we call test-driven development, right? So we're writing the test first in mind that someday we're going to have a function that's going to do something that we want it to do. And when that function exists, it should give the result that we expect. So test-driven development. So I created the test. Don't have the function yet, but eventually I will. And I'm going to specify what the test should be. So right now it says assert equal and it says true false. Now, do you think true equals false? True doesn't equal false, right? So in this case, right now our test would fail. So we need to replace these with things that we think are going to succeed. So true should be the expected result. So I'm going to put expected. Now notice how I write EX and it auto suggests for me the rest. I strongly, strongly, strongly encourage all of you to use this feature, to use autocomplete. Why? Because code is case and character sensitive. In other words, if you mistype a single character, your code doesn't work, you get a lot of wavy red lines, and then you're scratching your head for an hour. Why is your code broken? When your human eyes are not able to see that you missed a single character while you were typing. So I strongly encourage you to use autocomplete to autocomplete all your code. It's faster. It's also safer for you as a developer of tests. It's going to save you a lot of debugging later on down the line. All right, so expected result goes first, and then of course our actual result goes second. Now, trick question. What did I call my actual result? What did I call it? I called it output. Perfect. That's exactly what I called it. Okay, so now I have my test, right? I have my test. Now we are going to talk about creating that function that our interviewer asked us to write. Now, looking at this code, even if you don't know Python, right? And I don't expect anybody here to know Python. Can you guess what is the first step for me to create a function? So I'll give you a hint. This right here is a function. What we created right now. It's a special function. It's a test function, but it's a function. So if I want to create a different function, what do you think I'm going to have to do first?
Define it.
Yep, I'm going to have to use this special 3-letter keyword, def. Okay, so I'm going to take a couple lines. And then when you say enter, enter, it's very intuitive for you guys to start typing it right at the very beginning, right under class. But in Python, notice there's no parentheses to show where a certain block of code begins and ends. So Python actually relies on indentation to figure out which code belongs to which block. Okay, so there's different types of blocks in Python, right? One type of block is class, right? Another type of block would be function. We haven't learned yet, but there's also other blocks called, conditional statements. So if statements, there is, loops, so for loops. So there's different types of blocks. And again, all of these structures, the way that your IDE and your Python knows that, oh, this code is part of this block and this code is part of the other block, and how do they interact with each other is by the indentation. So in other words, if I want this function to actually be part of this class rather than outside of this class, it needs to be indented under this class. So it needs to be indented on the same level as this def. And in fact, you see that your IDE actually gives you this little line right here to show you where the other defs need to go. So I just need to get it to the same location. And usually if you tab, it will put it in the right location for you. So as you can see now, they're lined up, okay? They're lined up. And so everything is happy. So I already have a name for this function right here. That's what I'm going to call it. So I'm just going to copy the name there. And then I'm going to put an opening bracket, and it's going to put this magical word self inside for me. I'm going to tell you in a second what that self is. But so I'm going to put def, I'm going to put reverse string, and then don't worry about this. It's going to magically happen. All right. And I'm going to put enter. And as soon as I say enter, as you can see, it automatically indents for me. So your IDE knows that whatever code follows, it's going to belong to this block of code, this function, and that's why it indents it. So this code is part of this function, not outside of this function. Okay, hopefully that makes sense. So pay very close attention to indentation. Here, let me show you something. So right now, see, this code is not red, this code is not red, everything is good. But then if I do something like this, see, everything becomes red. There's red here and red here and red here. Everything just becomes discombobulated. So just that one indentation ruined everything. And it's even worse than that. Even if I do a single space, see, everything is broken. You guys see? I literally did one extra space and then everything turned red. So there's red here and red here and red here, it's all over the place. But as soon as I fix the indentation, all the red go away. And the only one remaining is the function that we haven't implemented yet, which makes sense, right? It's basically saying, I'm sorry, I don't know where this function is because we haven't created it. So pay close attention to indentation. I think that's probably the biggest issue with Python, that if you're just one space off, your code goes, and things get broken. So just, be careful. Okay, so reverse string. And let's write our code. So what do we want to do, first of all? So here we have this input, right? Here we have this input. What do we want to do to this input? Oh, I forgot one thing. Okay, so input, we actually want to pass into our function. So go ahead and put comma, and we're going to put input here. Okay, so we are taking our input, we're passing it into the function, and here we're implementing our function. Okay, so we are going to catch it here. And I'll explain it again if it's a little confusing, but essentially, let me do this. This code right here is your test, and your test is testing this function that we're creating right now. Okay, it's creating it right now, so it's separate. So forget about what's above right now. We're done with whatever's above. Now we're doing our interview. So our interviewer told us, I need you to take some input, reverse the words in that input, and and give it back as a string that has words in the reverse order. So here we have input, right? And we're going to say dot. Now give me a second, you guys. Sorry, one moment. Need to check something. Okay, sorry. Okay, so what we're gonna do is, you know what? Actually, let's do this. We're gonna do this little trick right here. Okay, that's gonna make it a little bit easier for us. As you can see, as soon as we put colon string, it's a suggestion. So before, when I put dot and I did, it didn't give me anything. It gave me all this junk. But then as soon as I did colon, oops, one more time, colon string, when I do control space, it gives me the auto suggest. So just to explain to you what I did, I basically told Python what type of input I expect. I expect strings. Now, again, this is not like Java, okay? In Java, when you say things like string ABC, right? It means ABC cannot take anything except string. In Python, this is a gentle suggestion. So it's like, it would be nice if you guys actually put a string inside here instead of some kind of other junk. But it's not strictly enforced. Okay, so input dot control space. What do I want to choose? What's my option here? What do I want to choose? What are we trying to do?
Split.
Split. So I'm going to do split. Now, when I did this, no, I guess it doesn't do it. Yeah, when I hold my mouse over it, so again, I'm not pressing control. See, my other hand is not pressing keys. When I hold my mouse over it, if I just kind of wait for a few seconds, documentation for this function comes up. So somebody was asking me earlier, is there some kind of documentation for all of these functions? There it is. Okay, so what you can do is you can, pick some of the functions there. So you basically say input dot, pick a function, and then just hover with your mouse over it, and you will see the documentation for it. Okay, and then you can read it and you can see how to use it and what it does. Now, if that's not really what you were asking me, there is also Python API documentation online. And so you can actually go to Python, whatever, 3.8, for example. And, ooh, I totally clicked on the wrong link. Let's do this first one. And you can go here, and then you can actually find all of the built-in stuff, sequence types, text sequence. Okay, I don't know off the top of my head where the string one is. I probably have to keep scrolling. But anyways, you can go through all of these. Lots of fun stuff to read through. And then you'll be able to find documentation for all of the string functions somewhere here. Mapping types, true values, Boolean comparisons, numeric types, array types, sequence types. Maybe here. Yes, there we go. We found it. So you can go online and you can kind of go through their documentation for Python 3, and then you'll be able to read documentation for each one of these functions, and it lists all of them out. So if you don't want to use the dots, space, and then finding the thing, you can just read through all of it here. I prefer to just do it the organic way. I do dot space, and then I find something that I feel sort of looks like something that I want, and then I try it out that way, and then
Ali, may I ask you, so for example, if you are creating tests, so how do you know that this function exists, or you need to write it yourself? Like, if you don't know, even if it exists.
You need to know. That's what I'm saying. You really should know Python about mid-level, right? And that's what you're doing right now. You're learning about all these functions, right? So I wouldn't send you to an interview without knowing Python at all. So you either
so the purpose is to know all these functions which are built in.
I don't know if you want to know all of them, but you should at least have a vague idea that they exist, right? Okay. So I really do not have the best memory. And I don't think it ever was like that. Even back when we didn't have Google at our fingertips, most developers had a whole library of books on their desk at work, and they would look up functions. So nobody is able to remember every single function in the language. It's just not what they find. Some people have photogenic memory, but not photographic memory, not photogenic, photographic memory. But most of us humans, we're not that good. So right now there's Google. And with Google, things become even easier. Like we have even less incentive to remember. So for me, I would say, the most common data types that you use, so like lists, dictionaries, strings, integers, floats, tuples, what else? Some other packages such as like sleep, date, math, random, all of common things that I'm going to cover in this class. You should at least kind of browse through them and read all of the functions and be like, oh, okay, yeah, I'm aware that they exist. If you go to the interview, you don't exactly remember specifically what the function name is, but you know that function exists, you can literally tell that to your interviewer. You can say, you know what, I don't remember the exact name, but I know the string object has a function that does this and this. I would say 90% of the time, your interviewer will actually help you remember the name of the function. The other 10%, your interviewer will pretty much say, you know what, whatever, just call it whatever. That's probably because they don't remember either. Like, they agree with you that function exists, but they're like, yeah, I agree, but yeah, I don't remember what it is either, so just not call it something. It will be like an agreement between you and I that, that's what the function is. So it's fine. But you should be aware of the fact that at least they exist and what they do, roughly, kind of, ish.
Okay, you know what I mean? Makes sense. Makes sense, yeah. Thank you.
Okay, so input.split. So do you guys remember what that's going to give us? That's going to give us a list, right? Now, what do we want to do to that list?
Reverse.
We want to reverse. Now, do we want to reverse it in place, or do we want to make a copy of it and then
we want to copy.
Yeah. So it turns out that if you want to do this all in one line, then you really should actually make a copy in reverse. If you want to do it in multiple lines, then it actually doesn't matter, but we are going to do it in one line. So we're going to say reversed, all right? And we're going to put it in parentheses, so this split. So this piece, you guys are familiar with it, right? This piece is going to go into this function as input, and this is going to reverse it. Now, this function reversed, when I used it in the console, I kind of did quick magic and didn't explain what I did. This function, it returns an iterable. So it doesn't return a specific data type. It doesn't return a tuple or a list or a dictionary or a set or any of those other Python types. It returns something that can be made into any one of those types, okay? So it returns kind of this blob that then you as the end user can choose to convert to any one of those data types. Does that make sense? So what you get back is a blob. And then what you need to figure out is what you want to turn that blob into. So in our case, we actually still want to get back a list. So very easy to do. There's actually a function called list, and you feed that blob into a function called list, and then you get back a list in reverse order, okay? So here, I'm actually going to take this thing right now, and I'm going to put the code in. But then instead of full name, instead of input, I'm going to put full name. So this is what we get so far. This is so far what our code does, okay? It takes our full name, it splits it, it reverses the order, and it combines it back into a list. Now, do you guys remember what the next step is? So we want to take this list and we want to convert it back into a sentence. How do we do that?
Join.
Somebody's asking me, there wasn't auto suggestion back in those days. No, when we were using books and there was no Google, there was no nice IDs. Now, IDs were very basic, and IDs wouldn't close parentheses for you. They wouldn't even tell you where the opening parenthesis is. They were essentially Notepad. Like, okay, they weren't called Notepad. They had some bells and whistles, but nothing close to what you see now. Basically, right now, code writes itself. Back then, no, you suffered. Like if you forgot to close a parenthesis somewhere, you spent a few hours trying to figure out where. It wasn't fun. So yes, so this one now, so now that we have this list, I'm sorry, I think, was it Olga or who spoke up? Somebody spoke up. Yes, join. Perfect, Olga. Thank you. So now we're going to join. So what should we use to join our words back together? What should we use? A space, right? Because it's a sentence. So we don't want stars or stripes. So we want space. So what I'm going to do is I'm going to say quotes, and inside the quotes, I'm going to put a space. All right, so that's what this is. There's a quote, space, quote, and I'm going to say dot join. And then this whole entire thing, again, goes into parentheses. So essentially, there's parentheses inside parentheses inside parentheses inside parentheses. And notice how helpful your ID is being. If you put your mouse next to a parenthesis, opening one, it will show you what the closing one is. And if you put it next to a closing one, it shows you what the opening one is. So it's very easy to figure out which one has a pair and which one doesn't have a pair, okay? This is why we like IDs now. IDs are awesome. So here we go. We have this piece of code, all right? Now, the last thing we want to do is, remember, when we call our function, we actually want to return the output, okay? So we call the function, we want to return the output here. Right now, the way that things are going, we are performing the operation, but we're not returning it back. It's just, it kind of happens and then gets lost. It's the same thing as here, right? If I do this, but I don't actually say equals and assign it to a variable, it gets lost. So what we need to do is return, and that's exactly what we're going to write. We're going to say return, okay? So we learned a new keyword. It's a reserved word. So in Python, the word return is special. You cannot call variables using that word, okay? It's a special reserved word, return. And when you say the word return, followed by some code or followed by a variable, whatever's inside that variable or whatever that code generates is going to get bundled up and it's going to get passed on to whatever, wherever that function got invoked. So that's what happened here. We took this thing and we returned it into our test right here. Now, as you can see, this thing is still complaining, And the reason it's complaining is because it can't find this reverse string function, which can be a little bit counterintuitive for those of us who are coming from C++ or Java background, because it's like, well, it's right there. Why can't you find it? It's right there. Well, in Python, if a function is part of a class, it gets stored inside self. And that's where this magic comes from, right? This self thing. So if you want to take things out of self, you actually have to say self dot. So that's what we're going to do right now. We're going to say self dot. And then as soon as we do that, the red goes away. So there's no more red. And everything is happy. Okay, so what I'm going to do right now is I'm going to just pause for a second before we run our code, and I'm going to go again through this code to make sure we all understand what we wrote, because this is a lot, especially if you do not know Python. This is a lot, so I'm going to go through it again, one line at a time, one piece at a time, and I'm also going to explain what self is. All right, so there's a certain rule in programming about when things are created and when they are destroyed, and having self is going to help us circumvent that rule. So here we go. What is self? Self is essentially a reference to the instance of this class. Let me rephrase this or explain this. A class is a definition. Think of it kind of as a blueprint for a house, all right? So when you are building a house, there's no house yet. There's just a blueprint, and that blueprint shows where the walls are supposed to go, where the entrances are going to be, where the windows are going to be. Like it shows you basically what your future house will look like. But in order to actually live in that house, or to use that house, to actually be able to open and close doors in that house, windows in that house, to put your couch in that house, or install, do whatever you want in that house, you actually have to turn that blueprint into an object, right? Like a real thing. And you can use one single blueprint to build multiple objects, right? So same in programming. When we create a class, it's a blueprint, and we can create multiple objects from that single blueprint. We call this process of creating objects instantiation, all right? So we create instances. That's why it's instantiation. So every single time this class gets instantiated, it creates an object. In other words, a new house, and another house, and another house. Now, all of these houses are going to be quote unquote identical, right? But they are separate objects. So you know how sometimes you're driving down the street, like in a new neighborhood, and all the houses look the same? Okay, fine, some are red, some are blue, some are green, but they're all the same, like the same garage, the same door, the same window, the same roof. That's because the same blueprint was used to build them. So same thing here. Different people can live inside those objects, but the object will look the same. Same thing here. We can instantiate this class multiple times, but there will be multiple objects, right, from the same class. They will all be identical, but there will be multiples. So the self right here, it's actually a reference to the object. So why do we do this? Well, when we create multiple objects, we don't want to get confused, which door belongs to which house, or which roof belongs to which house, or which, whatever, lawn belongs to which house. So self actually points to that specific object. So when somebody says input, right, or it says reverse string, right? When somebody says reverse string, so think of it as open door, right? By saying self.open door, we're specifying which house specifically needs to open a door. If we didn't use self, or if it didn't exist, then when we said open door, all of the houses would have the door open. And that would kind of be a bummer, right? You have like 12 houses on the street. Somebody says, hey, open the door. And then all of a sudden, all the houses on the street have the open front door. So that would be bad. So self right here is a way to point to only one specific object that was made from this blueprint. And this self gets created when we create an object from this blueprint. So it gets passed in. That's why you see it being passed into every single function. Now, the next question you should be thinking to yourself, okay, finally, I get it. My test case is a blueprint, and objects are going to get created from it. But who is creating objects from this blueprint, right? Who is doing that? Well, actually, unit test is doing that. So when we run this code, we're going to run it as unit test. And the unit test framework actually goes and finds all the tests inside this class, and it is going to create a separate instance per test. of this class. And then when it creates that separate instance per test of this class, it's going to pass the reference to that object inside the test function so that you can continue calling other things on it and performing whatever things that you need to perform on it. Did that sort of make sense-ish? I hope it did.
Okay.
Good.
Quick question.
Yes.
So is self returns to the method or to the class? I mean, to the method test something
Self
or to
is
the
a pointer to the object that was
pointer.
made out of this class. Okay?
Okay.
So let's say that we have a class called building, all right? And we create one instance of it called blue house, and then we create one more instance called greenhouse. Well, self will actually be a reference to that specific one house. So a single self inside blue house will be to the blue house, and inside red house will be to the red house, and inside the greenhouse to the greenhouse, so that they don't get confused. That way, when you're running code inside that object, so when you're inside the greenhouse and you're like, I'd like to turn on my stove, you would actually say self dot turn on stove. And it won't happen in all the houses. It will only happen inside the one you're currently in. So if you're inside greenhouse and your self refers to greenhouse, it will know, okay, the stove needs to be turned on only inside greenhouse. Kind of? Yes? No? Maybe? Ish?
Kind of.
Okay. All right. Okay. So that's what self does. Now there's a second thing that we use self for. Self is also a container that will not be destroyed. So there's this rule in coding that whatever gets created inside a block also gets destroyed inside that block. So in other words, as you can see, this is a block. How do I know this is a block? Because all the code inside it is indented, right? So this starts the block, and then everything that's inside it is part of it. This next line is indented back out. So that's the beginning of the next block. That means the previous block ended, new block has begun. All right, so if we look at this piece of code as a block, this variable is created and instantiated, right? Initialized, not instantiated, sorry, initialized inside this block of code. That means when we're done running this piece of code, this variable will not exist anymore. It will die, okay? It will be cleaned up, it will be destroyed. Same thing here, expected result, it only exists as long as this test is being executed. After this test finishes, it gets destroyed. Because of this limitation, when we call reverse string, there's no possible way for this code right here to have access to this code. The code inside this block does not see code inside this block. They do not see each other. So for whatever reason, you needed to pass information from one function into the other function, there's two ways to do it. You can either pass it as a parameter, which is what we see happening here. So we call the function and then we put it inside parentheses. So when that code arrives into the function, it gets lent inside those parentheses. Does that make sense? So we call it and we say, here, catch. And then that function says, oh, okay, yes, I caught it in my parentheses. So think of it as like a mailbox, right? We put it in the mailbox to mail it out, and this got it into a mailbox to receive it into its own mailbox. Or you can actually put things inside the self container and then take it out of self container. So here, I'll give you an example. I could do things like this, self.message equals hello world. See, somebody wanted me to do hello world. There you go. And then over here, when we get into this function, we'll be able to say things like self dot, and look, see, message popped up. Before it didn't exist, that message, right? And so now I can say things like print self dot message. What do you think print does? What do you think? If you're coming from Java, if you're coming from Java, it's the same as system.out.print, right? You just don't have to put system.out in front of it. It's shorter, but the same concept. Okay, so from the beginning, very first line imports the all-important unit test package, which is essentially the unit test framework. Then the next line, we declare a class. We give it a name. It doesn't have to be called my test case. It can be called test string reversal or whatever you want to call it. Doesn't matter. The name really doesn't matter. The only place where this is actually going to show up is in your test results. Okay. Then this next part over here, next one, it says, well, we imported this unit test package. Now we would like to take advantage of all these awesome bells and whistles that unit test has. And by what actually is happening here is inheriting. By inheriting from the test case class, we're going to get some amazing additional functionality. So we're going to be able to set up our test, clean up our test if we need to. We haven't done that yet, but we're also going to be able to use all of these assert statements. Okay, so these assert statements right here, they actually come from here. All right, that's why we're able to say things like self dot, because it actually comes from here. It's also by doing this, we're also telling Python how to execute our code. And so now our Python knows that if there are any functions in our code that start with the 4 letters TEST, it means those functions need to be executed first. If there are any functions that do not start with TEST, they need to be ignored. And so then it's up to us from inside our test to call those functions, which is exactly what's happening here, right? We're using our test to call reverse string. Okay, next line. This is the beginning of a function. So we're saying def. That lets Python know that we're going to define a function. And here we're defining a basic test. All functions that are part of a class are going to get this magical self passed into them. This is not something we have control of. This actually happens automatically. All functions inside class will have access to this self parameter. It's called a parameter. Okay. Now, what I did here during this line 6 is I'm just demonstrating that if you want to store something inside this self container, you absolutely can. Okay. And so here, when I said self.message, I actually just, this is something that I came up with. It's a new name. So I created a new container, but instead of creating it inside the function, I created it inside the self container. Does that make sense? So this is actually a container inside a container right here. And I'll show you later when we do debugging. So you'll actually be able to see it with your eyes. So it will make sense. Okay. So here I'm creating a container called message inside a container called self that we got as a parameter from unit test when it created an instance of this class. All right, let's keep going. Now, this next line, I'm also creating a container called input, and I'm specifying what my interviewer wants me to use as input, right, to reverse. Again, I'm creating another container called expected result, and here I am the interviewee specifying what I believe the expected result should look like. Now, I'm also going to show this to my interviewer and say, do you agree? This is what you want. And the interviewer is going to say, yes, that's what it should look like. I'm actually going to check that. Yeah, good. Okay, now I'm essentially saying, all right, I wrote some code, right, my reverse string code that I think does what you, the interviewer, wanted me to do. Let me test it. So I'm going to call that function, pass in the input, right? And I'm going to get the output back out. Get it back out. And then one final step right here, I'm going to call self.assert. Now again, I already explained that in programming, when we want to check something, we're going to use the word assert. So in other words, what this line of code means is check that these two things are equal, right? Check they're equal. And so I am checking that the expected result and the output I got from my function are equal. And that's how I'm able to test that, yeah, okay, I did a good job, right? And so my interviewer doesn't have to tell me, oh yeah, you did a bad job or a good job. My test will tell me. And then the interviewer will say, hey, good job. Not only did you write your code, you also tested your code. Props to you. Okay. And then finally, this is actually the function that actually does the heavy lifting. So this is a test. This is a test. This is the function that actually does the reversing. It actually reverses a string. And actually, we probably shouldn't have called it a string. We should have called it reverse sentence, but we'll rename it later. Okay, so what does the function do? Again, this was strictly for demo purposes. This is not any kind of important code. Let me put a little comment. I'm going to say code to show how to view items inside self. Okay, now notice how I put a comment. In order to create a comment, I just put a hash sign. Okay, so if I want to comment something, I just put a hash sign, and then I can leave myself a little message. This is to show how to store data into self. Okay, now I have two comments, one here, one here. So you can do one on a separate line, and then you can also do one in line. Either one is fine. Okay, now how do we run this, right? How do you run it? I don't know if you noticed it, but there's a little green triangle right next to the test, and there's another little green triangle next to the class. What does this mean? It means I can run the test by itself, or I can run the tests inside of the class, all of them. Now, at this point, it doesn't matter because we only have one test. So you can choose which triangle you want to press. Doesn't matter if you want to press this one or this one. You will still only run this.
Well, it's going to fail. Actually, there is a miss end in the expected result.
I'm sorry, one more time. What?
Yeah, I mean, the test is going to fail, I guess, because there's missing end. Roses are red, and I'm glad. And if you read it back in the expected results, roses are red, and there should be end between I and red.
Oh, okay. Well, that's good. Actually, let's see what happens when it fails. And this is actually exactly why I write the test, even during the interview. Okay, this is literally what I would do during the interview, because this will actually show me what's wrong. Okay, so this is good. We actually, I couldn't have planned it better. Let's pretend that I planned it. I didn't, but we're going to pretend that I planned it. Okay, so let's go ahead and run our test. So go ahead and click on the little triangle, and then what you're going to choose is run. Okay, and the option will say unit test. Okay, it will say run unit tests for, it cuts off the name, but it's essentially a reverse reverse string. That's what it says here. Or I'm sorry, reverse order. It says run unit tests for reverse order. Okay, so we're going to click that, and then we're just going to step back and wait for the magic to happen. It's pretty quick magic, not a very long magic. So this is what happens. Okay, it pops up a panel for you that's called run, and it's also going to show you what failed. So over here, it shows you what the name of the package is, and then what the name of the test class is, and then what the name of the test is. So you're able to drill down. Now, this is not very impressive because we only have right now one class. No, I'm sorry, one module with one class with one test. But if you had one module with 20 classes and each one of them had 13 tests, then that would be pretty impressive, because then you can drill down, into each test one at a time to see what failed, and it will make it a lot easier for you to find things. So you can actually click on things and it will take you to that location. So here we go. Let's see what happened. All right. First thing we're going to notice is that we see hello world, right? So the obligatory hello world got displayed. Where did this code come from? Do you guys remember where it came from? Can you tell me what line number this code came from? What line number is responsible for this hello world right here? Yes. Okay. We have one answer. Good. Okay. So the line 15 is responsible for this code right here. Okay. This is the line that's responsible for hello world. Now, some of you entered 7. 7 is where we stored this. So this is where we took this string and we put it inside self.message. However, the actual code that prints it out into the console is this code right here, the word print. So the actual printing happens on line 15. The storing of the string happens on line 7. So 7 is almost correct, but the actual action gets performed on line 15. Okay, what else happened? Well, the next thing we see is it says glad am I and roses are red does not equal glad am I, red are roses. All right. And so we agree. Then it also lines them up for us so we can really see what the differences are. So as soon as it lines it up, even me, who is very bad at, obviously, I read this thing multiple times and didn't see the difference, I would still be able to see, oh, yes, okay, I see what happened here, right? I'm missing and because that's when they stop being lined up. So that's when I'm going to go in and I'm going to say, all right, time for me to fix it. So I can, I can fix it. And then if you didn't know where you're supposed to fix it or where the failure occurred, there's also this thing called stack trace, okay? And so the stack trace usually gives you kind of a rabbit hole, essentially, of how this failure got propagated. So it's going to tell you it failed here, and then it went here, and that also failed because of it, and then it went here, and that also happened, it failed because of it. So the way it works is usually what I do is I scroll through the stack trace and I find the first line of code that's actually my code. So in other words, I know that this, I didn't write this code. Unit test that, /case, that's not my code. I didn't write it. So I'm going to assume that that code has been well debugged. That code is not what broke. I don't have to worry about that code. So if I go and do that, if I go and I say, not mine, not mine, not mine, oh, okay, that's mine, then, I can tell that that's actually where the issue happened, more or less. La, 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 la. That's also not mine. I was just showing you. Okay, so on that note, I fixed it. And now what I can do is I can either run my test again from scratch, or there's this nifty button right here. And so there's this, run button, but right under it, there's the triangle with a red exclamation mark. And what that does is it only reruns the failed tests. So in other words, if you have a suite of 100 tests and 13 of them failed, and you fixed some of those 13 tests, right? And now you want to rerun just those 13 failed tests. You don't want to rerun the whole 100, right? Because like maybe 100 takes half an hour to rerun, but 13 obviously will only take you 5 minutes, right? You don't want to run half hour. You just want to rerun the ones that you already know were failing, and you want to check that you fix them. So this button is your best friend, okay? This will only run the ones that failed. And if you fixed 13 tests, or you thought you did, but then 3 of them are still failing, then you can, go back and fix the 3 that are remaining and rerun them again. So each time it's going to make it smaller, 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 until all of them are passing. So that's what we're going to do right now. We're going to experiment with that button. We're going to press it. It's going to rerun things for us. As you can see, it says tests passed. And you can see what happens when tests pass. It's actually not as exciting as when they fail. Failures are actually more exciting. Pass, it just says everything was okay. That's it. You're like, all right, it's okay. And then it says, hello world, because that line of code that prints that out is still there. Your test failed. No, what happened? All right, so I'm going to show you how to debug, and maybe then you guys will figure out how things failed and where. Okay, so here's how you debug. I don't know if you guys noticed this, but I did this, right? I did this like red little marble. That's actually called a breakpoint. And I can set as many of these as I want. So I can actually put one here, and I can put one here, and put one here. I can put one on every single line if I want, okay? But go ahead and set 3 randomly. It doesn't matter where you set them, just so you can play around. So go ahead and make a couple of these marbles on your code. Here's what I'm going to do, you guys. I'm going to copy this, and there was a way for me to share a file. Sharing, no, dashboard attendees, audio web compose, handouts. Oh, okay, fine. Okay. Why is it not supported? Hold on, I wanted to actually share my code with you so you guys can have it, but it's saying it's not supported. Why not? Really? TXT is not supported? You're kidding me. Okay. All right, so this is my Python code. I put it inside the handouts location inside our webinar. When you download it, make sure you change the extension from doc to py. All right, but essentially now you have, my code more or less. So I'm actually going to check to see if it works or not to open it. Yeah, so yeah, just rename it back to py and it should be fine. Don't open it as a doc because it's gonna screw things up. Just rename it to py and then you'll be able to open it. Yes, I'll show you again how to make a breakpoint. Oh, okay. Expected glam in my red roses. Okay, that's because when you did a join, you didn't put a space. You forgot to put a space between the quotes. So when you did your join, make sure you put a space. Otherwise, I think you did everything good. And then also there's that comma. So that's why when I wrote my input, I removed all the punctuations. Things become a little bit yucky when you put punctuations in. So I removed all the commas and periods to keep it simple. So remove your comma and then also add a space inside your join. Yes, I'll show the red things in a second. Well, assert equal, the output is this. When you see OK, that's actually it passing. And that other statement where you saw it said failed, that was it failing. That's literally the output of assert equal. That's what assert equal does. So in fact, you know what? Let's do that. Let's go ahead and hold down our Command/Control key and click on assert equal so you can see what it does. It's basically, I'm going to make it that simple, but okay, fine. It's a little, they make it a little more complicated now than it used to be, but essentially it throws an error, it throws a failure when things don't match. So that's why you saw this whole stack trace and the red over here when things did not equal. And that's why you see OK when things pass. That's the output of that statement. Yay! Woohoo! You're welcome. See you Monday, hopefully. Through line number 16 again. Yes, so let me first answer the first question, how to add these red things, and then I'll go through line 16 again. Absolutely. Okay, so let's do this. First of all, in your editor, if you double click on this tab over here, it will make it nice and big. So in your editor, you may or may not have these gray lines. So let me disable them so it looks like yours. So yours looks like this, right? You need to make sure that you click not on the white part, but on the gray part, but also not where the actual tabs are, right? So not where the tabs are and not where the code is. You need to click on the gray part that's the margin.
All right, and then there's really nothing you need to do. You just click. You literally just click and they should appear. The only place you can't click is where the comments are. So like you see how there's a comment here? I can't put a breakpoint there because it's not code. It's a text. Anywhere else where there is code, again, you can't put a breakpoint on a blank line. So if there is empty space there, you can't put a breakpoint. But everywhere else, if you just have to click it, it will appear. You don't have to right click it. You don't have to do anything fancy on it. You just click once, like you would a button, and it will appear. And then if you want to remove it, you click again and it disappears. So hopefully that worked for people. Now, if you want to add line numbers, that same margin where I have my dots, if you right click, you can enable show line numbers. And that's why I have line numbers. First of all, it's easier for me to explain my code because I have line numbers, but it's also easier to create breakpoints because you have more area to work with. There you go. All right, so guys, let's go over line 16. There's a lot of things happening here. So what I'm going to do is I'm going to break it apart into pieces. So the first piece is we have input dot split. Okay, and so what that does is creates a word list. Okay, and you'll notice that I can't spell to save my life, so don't judge me. So here's a word list, right? Okay, that's the first step. Then what we do is we take that word list, so list of words, and we are going to reverse the order of it. So we're going to say reversed, and we are going to pass our word list inside. Now what that's going to do is it's going to give us back a blob, okay? It's an iterable blob. So let's call it unstructured data in reverse order. We'll do cell documenting code. Okay, that's what we get here. So in order to give structure to that data, we are going to put it into the list function, and it's actually going to take this unstructured data and turn it into a list. So that's what happens here. New reversed list. That's what happens here. Now, once you have this new reversed list, what you want to do is you want to combine pieces back into one whole. Now, the way sentences work is we have spaces between lists. So that means when we cut our sentence into pieces, spaces were taken out. So we need to add them back in. So what we're going to do is we're going to put, two quotes, single or double, and we're going to make sure that there's a space between them. Space between them, and we're going to say dot join, and we are going to put our new reversed list into the parentheses, okay? And that's going to create our new sentence. And then finally, what we're going to do is we are going to return our new sentence, okay? So all of this code right here, and by the way, right now I'm doing a comment. The way I'm able to do this is I highlight all the code I want to comment, and I do command for Macs and then slash, or on Windows, it is control slash, all right? So command slash control slash, and see, I will put, so I do one of these, that kind of slash, all right? So I do command plus slash to do a comment on all of these. And on Windows, it would be control plus slash, all right? Everybody got it? So I highlighted all this code and I did that and it commented all of them out. So all of these lines of code equal this one line of code.
And can I ask a quick question here?
Mm-hmm.
So why, when you on the line 16, you have that word list defined, right? And you say input that split. Why you don't provide what exactly you're splitting with in double quotes, for instance,
Excellent
space?
question. That is absolutely awesome question. So if you hold your mouse over split and you read
Okay.
the documentation, you'll see, I think they say it somewhere, that by default, the default for the split, the separator is actually a space. Let me see. Let me recommend we split the
Oh,
screen.
by default, okay.
Blah, blah. Yeah. So
so if there was a comma, then we would have to, if there was a comma in the sentence, we would have to provide that comma in
if
that.
you wanted to split by a comma,
Right.
you would just put a comma. Yeah. But if you want to split
Okay.
by space, that's already the default. So you don't have to provide anything. Absolutely.
Okay, and if there is a comma, can we split it by space?
Yeah. Yeah.
Okay.
So here, since you asked it, roses are red, comma, right? But then your expected result would be like this. So your comma will stay with red.
What if there won't be a comma? It will fail, right?
No, if we remove it, it will fail because
Okay.
it will still, like, it won't be missing this.
Okay.
Now,
Thanks.
some of the interviews that I go to a little bit more complicated ones. So they give you more complicated problems. They might ask you to, also deal with those punctuations. So they either might ask you to remove them or to actually phrase them correctly. So reverse the string and then also make sure that, for example, exclamation mark is at the end still, so it doesn't actually lose its place. Or, a comma is still after a third word, not, something like that. So they might still do something funky like that. But most of the time, it's just simple like this. There's no punctuations to deal with. Coolio?
Yes, thanks.
Okay. All right. So I asked you guys to do breakpoints. The reason I asked you to do this so I can show you how to debug. So here's how you debug. You set your breakpoints. That's step number 1. You have to have at least one breakpoint. Otherwise, this is not going to work. And then when you click on the triangle, instead of selecting run, you're going to select debug. Okay? So don't select run, select debug. And what happens is, instead of opening up the run, tab panel, you will actually see the debug panel. And the debug, I can't talk to you guys. The debug panel is pretty interesting because it will pause on the breakpoint. So it will not run all the way through the code, it will pause. And it will actually pause before the breakpoint. So in other words, even though this line is highlighted, it has not been executed yet. Okay? Not only that, but just like when we use the Python console, we get that little thing back that shows us what's in memory. So right now, when we just started our test, right? Our test just started, there's only self. The only thing we have right now is self because that got passed in. So we can actually see what's inside it. See, there's already some stuff inside it. And you can, unfurl it and see what other things that you can say, all the protected stuff that's coming out. So for example, outcome, errors, lots of things. Okay, you can play around with that. But then once we do that, what we can do is you can use these buttons over here, right? All these buttons to actually step through our code one line at a time. So the very most important button that you need to learn is this one. It's called step over. And this actually lets you go one line at a time. So go ahead and click it once and then just kind of see what happens. I'm going to click it. See, it executed just that one line, went to the very next line after that. And what you can see right now in your little window that shows you what's in memory, you can see that inside self, right? Inside self, a new container was added called message. It wasn't there before. You can see that it wasn't there before because it turned blue, right? It wasn't there before, and we stored hello world inside it. Now, if you go to the console, as you can see, there is actually still nothing here. So hello world hasn't been printed out. It's just been stored. So it's been stored. It's in memory now. Now, if we do the arrow again, you will see that not inside self, not inside, outside of self, there's a container that's been created called input, and that's what's inside it. And so you basically can keep going step, 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 and see each time what got created. And if you have a whole bunch of things, the new ones or the changed ones are always going to be blue. So you can find them pretty easily. They get highlighted for you. So here we go. Right? We were here on this line of code, output, but when I said step, as you can see, it did not go to the next line. It actually jumped here. Why do you think that happened?
There is no breakpoint in there, so it's
Actually, the reason it did was because there's a breakpoint here. So
oh, sorry.
This is a breakpoint, so it stopped here, but it couldn't go to the next line because this breakpoint is actually before that line. So think about it this way. This line of code calls reverse string, so it actually is going to come here. And we have a breakpoint inside reverse string. That's why from here, it couldn't go to the next step. It had to go to the next breakpoint. That's what happened. This breakpoint is before this line of code. Does that make sense? So this code calls all of this. Therefore, we had to go from here. All right. So again, I want to show console to you. See, nothing in console right now. But right now, when I click the next step button, you will see hello world. Okay, see that? Got printed. So it happens here on line 15. And then over here, when we do the next step, let me go back to my debugger. Okay, we have our input. Oops, I should have commented that out as well, but it's okay, whatever. That should be commented out. So what's going to happen on this line is all of that stuff is going to happen and it's going to get returned. So we're not going to see the output of this. We're only going to see it once we get back here. And so output is going to get instantiated. So here we go. We're going to do step, jumps back, and then we have to do another step to see what's inside output. So output is that. And then finally, we're going to do our assert. So there we go. After that, it kind of starts bouncing you around to all kinds of other places that you don't want to be. This is actually unit test. So if you ever end up in this file, case py, you can just either press the stop button or the resume button, which will take you all the way to the end of the test. You don't actually have to keep pressing step, step, step. Okay, so that's what happened. That's how you debug. So you can go one line at a time and figure out which line is broken, and you can see which line does what, and you can actually drill down over here in variables to see what's inside every single variable. So if you're ever in doubt, you're like, I don't know what this code does or what's inside this variable, you can actually see it here by doing breakpoints. Another last thing I wanted to show is when you're in debug mode, if you don't want to go step, 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 if you want to just jump from one breakpoint to another breakpoint, you can just press the resume button. So for example, right now I'm here. If I press the resume button, it will jump all the way inside here. So we'll go resume. And if I press the resume button again, then it will jump here to the next breakpoint. And if I press it resume again, then it will take me all the way to the end of the test. So there you go, the test is done. Make sense?
Yep.
Yay, I'm glad somebody found this good. Yes, so without self, in this case, we won't be able to do assertions because assertions actually come from here. So if we didn't have this bit, self would actually not have any asserts inside it at all. And you can actually test this out. So right now, as you can see, lots of asserts. But if you do this, and you do control space, no asserts. Okay, none. They went away. And obviously, if you don't pass it in here, same thing. It's just going to scream, I don't know where self is. And it's going to yell at you. So yes, you can't test things. You can define variables, but not inside self. So here you're able to define them inside the function, but you wouldn't be able to package something into self and then take it out later in a different function. I was going to have us talk a little bit about API package today. So we have just a little bit of time left, about 8 minutes. let's try to see if we can quickly do something fun. So I know this is called test something, but let's not call it test something. Let's call test reverse string. And then we actually will create another test that will actually test something else inside the same class. Or maybe I shouldn't do it the same class. Let's do a different one. It's fine. So go ahead and save this one. Actually, you don't have to save it. So something to realize about this IDE, every single character you type, it saves. So after every single character, it saves. So you don't have to worry about not saving or saving your work. It saves automatically, every single character. So you can just close it, and it's going to be saved for you. Go ahead and create a new. You guys, you don't have to do this. I was just, trying to be helpful. So let me delete that. So go ahead, and we have just a little bit of time left, but go ahead and right-click on tests and say new. And we're going to say, again, Python file. It should be familiar now, so it should be easy. Again, we're going to create a Python unit test. And we're going to call this request demo. Request demo. So again, it's going to create all of this stuff for you. I'm kind of a fan of making sure that I change things to be called what they should be called. So now somebody asked me about capitalization earlier. I just like to point out that because this is a class, I do capitalize it. That's still a thing. So classes should still be capitalized, but your test, your file doesn't need to be, and your functions are also not. And then we're going to put test get Google. We call it test get Google. So last thing for today, we're going to try to get through this very, very quick, just for the fun of it. Okay. So in order to perform API requests, there is this really awesome library. Okay. And it's called requests. How do you install additional libraries using Pycharm? So what you're going to do is, if you're on a Windows, you're going to go to File, and somewhere over here, I obviously don't have it because I'm on the Mac, but somewhere over here, you will have settings. It's either going to be called settings or default settings. But somewhere over here in your list, about here-ish, you should have the settings option. Okay? Now, if you're on a Mac, you're going to go under Pycharm, and you're going to select preferences. All right? So one more time, you're on a Mac, you're going to go Pycharm, preferences. You're on the Windows, you're going to go File, and then you're going to choose Settings somewhere here. Okay? There's only one type of breakpoint. There's no different types of breakpoints. They're just, a place where you take a break. So, but you can put them all over the place, and that makes them useful. So I'm going to go to my preferences. Those of you who are on the Windows are going to go to settings, and we are all going to end up with something that looks like this. All right, now it might not look like this. It might look something like that. All right, so you will end up somewhere that's more or less looks like this. So you're going to have a big window. On the left side, you're going to have a list of things. On the right side, you're going to have some other stuff. What you want to do is you want to go to where it says project, and you want to unfold it, and you want to choose project interpreter. Okay, so one more time, project interpreter. Now, most of you will not have this much installed. Most of you will only have pip, setup tools, two other things that I'm totally forgetting right now. But anyways, oh yeah, I think 6 and anyways, you guys get the point. You'll have 4 things maximum. I have a lot of things because, I use Python all the time. So what you want to do is over here in your list, you want to find the plus sign. Again, if you're on the Mac, it will be on the bottom. where my mouse is right now. If you're on a Windows, it will be on the right side. On the right side, it will be bigger, it will be a plus sign, and will probably be blue. So on a Mac, it's going to be on the bottom. On a Windows, on the right. What you want to do is you want to click on the plus sign. Okay, so step 1, click on the plus sign. Step 2, search for requests. Okay, REQUESTS, requests. Search for it, and it will literally be the very top result, the one called request. So once you find it, all you need to do is go to the bottom of your screen and click Install Package. That's it. As easy as pie. All right, so I'm going to do it again.
What can I do if I have a Twitter request, CX request, and so on? Not the request.
You just want the one that's requests, no other nothing. Just the very top result, just the one that's called requests. No other bells and whistles. So one more time. On a Mac, on the bottom, we're looking for a plus sign. On the Windows, on the right, we're looking for a plus sign. We're clicking the plus sign. Okay, so step 1, click the plus sign. Step 2, look for requests. And again, if you look at my screen, there's like a million of them. Okay, I don't want a million of them. I just want the one that is requests by itself. No dashes, other things that follow it, nothing, just requests by itself. And then you're going to select it, and you're going to click Install Package. That's it. You're going to have to wait a little bit, but after it installs, it's going to say Package Requests Installed Successfully. You're going to get this green thing on the bottom of your screen that says things are A-OK. And that's what we are looking for. We want things to be green. After that,
may I ask a question? Sorry. May I ask a question? Is it the same thing as pipe? I mean, pipe install something,
well, pip,
and
it is actually.
okay.
It's not the same thing. It is pip. It's just your
Okay.
IDE's nice GUI way to call it.
Okay, got it. Thank you.
Yeah. Okay, so I installed mine. After I see this green confirmation, I can just close it. So close it. And then over here, I'm just going to say OK and also close it. And now I'm ready to use requests. So I now have this stub, right, that I created right here. It says import unit test. And then it says request demo, test get Google. I'm ready. I'm ready to write my test. So the very next thing I'm going to do is on the very top of the page where it says import unit test, I'm going to make one more line. And I'm also going to say import. But now I'm going to say request. And when you start typing, as soon as you type in RE, you will get a list. And the second option will be requests. So you don't even have to type it out. You can just double click. There you go. You have requests. Now what you're going to do right now is inside your test, so wherever it says def test Google, get Google. Again, you're going to make an empty line, after the definition, before your assert, and you're just going to say requests dot, and as soon as you say dot, you get an entire list of possibilities.
So Ellie, it's not going to import automatically when you start typing inside of the function request. You have to do it manually first on top, and then only you're going to be able to.
Yeah, actually, you can do that as well. So here, if you just want to type it in like this, requests, it will show it as red, and then you can just say import this.
Okay.
Yeah, we'll do it. That's fine. Either way. So request dot. And so I guess I kind of once again will encourage you to look through all your options. I will call your attention to the most important ones. So number one important one, of course, is get, followed by delete, post, put, patch, options, and head. Now, again, today is the very first day, and I'm kind of trying to give you a taste of everything. We're going to talk a lot more about, why requests, what are the different requests, what all of these mean. Today, I'm going to do the very most basic one because we're actually like 2 minutes over time, just to show you how you would make a request. So just to kind of, for those of you who don't know what requests are or why we're even talking about them, part of this class is to learn API automation. And what are APIs? Well, APIs are, let me open a new tab. Okay. So APIs is actually what your browser uses to retrieve information from the web server or application server. So let's pretend that you want to go to Wells Fargo, for example, or you want to go to Google, or you want to go to Facebook, right? It doesn't matter where you want to go. As soon as you type in a URL inside your browser, and that's what I'm going to do right now, I'm actually going to type in Google, and you press enter, what your browser does is it actually executes a request. So that's what we're seeing here on the bottom. All right, it executes a request, and it gets back a response. It gets back a whole bunch of different responses. So let's look at it a little bit closer. All right, so I typed in Google, and what your browser actually did is it went and it went to Google and told Google, search for Google, right? That's what it did. It's a little bit funny. Now, the reason it did that is because my URL field is actually configured to also be search for Google. It's actually a search site for Google, okay? But essentially, if I was already on Google and here, let me clear this again, and I wanted to search for another keyword, let's say Apple, right? And I say search. Let me too much things. Search. So again, same thing happens, all right? Same thing happens. It performs a search, and we can see that search. So again, it says Google, right? Search, and then it passes in parameters for what it wants to search for, okay? So it doesn't matter what you do in your browser. Anytime you click on an item, so for example, I click on Apple, right? What happens? It does a search. It performs a search. And here you can actually see what it does. It performs a request, and that request's name is what? Get, right? And then it shows you which URL the request is being addressed to over here. Well, I mean, I clicked on Apple website, so of course it went to apple.com. And it also shows you all kinds of information that it passes along with that request. So it also tells the browser, for example, what is your user agent, okay? User agent. Remember earlier when we downloaded Pycharm and when we downloaded Python, the website magically knew what kind of executable you need? Like for me, it automatically knew that I need a DMG, but for those of you who are in the Windows, it automatically knew that you need an EXE. It's not really magic. What happens is when you arrived to that website and you requested the page, you passed in the user agent. And your user agent literally says, it tells it what kind of computer you're on. For example, mine actually says that I'm on Mac OS X. So right now, if all of you, feel like it, and you right click and you say inspect, right? And then you open up the network tab. Doesn't matter what kind of request you perform, anything. If you look at your headers for that request and you go down to where it says user agent, you will be able to see the same thing. So for you, the Windows users, it will show something along the lines of Windows NT or Windows something, like it will say Windows. And for those of you who are on Linux, it will say Linux. It will say something like Red Hat or Solaris or anything along those lines. And then, of course, for us Macs, we will have Mac. Okay, so it's not magic. It's just when the server on the Python website or the Pycharm website received a request from you, it also learned that information from your user agent. So it intelligently offered you the best option for you given your computer. Okay, so that's what we're going to do right now. We're going to do manually. We're just going to get Google. So we're going to say request.get. And it's not cooperating. I don't know why, but okay. And then, of course, if I hold my mouse over this, it tells me what kind of items I need to pass in. And so as you can see, it says I need to pass in the URL, okay, number 1. And then I can also pass a whole bunch of parameters and keywords if I need to. I'm going to keep it very simple today. I'm just going to pass in a URL. So in quotes, we are going to say something like http://www.google.com. Now, I want us to save our result. So I'm going to say response equals. And then over here, instead of saying assert equal, no, actually it's fine. I guess we can do assert equal. So let's put 200, and then we're gonna say response dot. We're gonna do status code. Okay, status code. So here we go. That's our test. Let's go ahead and quickly run it. A very basic test right now, very simple. So what we're doing is we are making a request to get Google, and we are checking that it's a successful response. So in other words, if for whatever reason we're not able to get Google, this won't be 200. Those of you who are familiar with some, API response code, so 200s are usually okay. It doesn't have to be like 200. It can be like 200, something 210, 220, but anything in the 200 range is good. Anything in the 400s and 500s is bad. Anything in the 300s usually means that the website has moved. So 200s, yay. 300 depends. 400, 500 bad. So here's what's happening here. We are asserting that yes, we were able to get Google, and the response was 200. So let's go ahead and run our test, which is going to say run. And then, of course, it comes back quickly green. Now, those of you who are curious, you will say, Ellie, but how can I see that it actually worked? I don't really trust this whole 200 business. And that's why I'm going to reply to you and say breakpoint. So I encourage you all right now to make a breakpoint where it says response and debug. So you are going to, again, set a breakpoint, say debug, right? And then you're going to do a single step. So what you want is you want to pause where it says assert, but after you actually get a response back. So right now there's no response. So I'm going to do one step. I'm going to see that there is a response, right? So I got my response. And then if I unfold my response, I can see all kinds of stuff inside, all kinds of things. And one of them is called content or text, whichever. They're actually the same. The only difference between content is binary and text is string. So you can look at content, and as you can see, it's HTML. So you got your HTML back. Status is 200. Reason is okay. All this other jazz. You can look at any of the links, redirects, history, everything. Okay. So yeah, any questions? Obviously, I'm trying to make it very quick, but next class, I'll show you a lot more. I'll show you how to take that content and convert it into HTML and store it into a file so you can actually see that the page came back using your own eyes. I'll actually also show you how to set headers so you can not only get information, but post information. All kinds of fun things.
And a quick question regarding the syntax. So there is no curly braces, right? There is semicolons for the blocks.
Yes, in Python. We have curly brackets in Python, but they're not for blocks. They're for dictionaries. So yeah.
Okay.
And we're going to talk about dictionaries next class as well. I mean, not everything in one day, but yeah. Okay, you guys, that is essentially the end of class. Any questions?
Any homework?
Oh, sorry.
Sorry.
Go ahead.
Go ahead. I'm on mute.
So homework, absolutely. I don't really have right now anything off the top of my head, but I think let me kind of I guess mull it over, and I'm just not sure how I would be able to post it because most of you are not on my Slack channel. Here, let's do this. So actually, it's not. It's not. So this is my email. It's blackellie@yahoo.com. So I don't have a homework right now, but if you're interested in getting a homework from me and like trying something out before Monday, send me an email before Saturday morning. Like, okay, I'm not gonna respond to you before Saturday, but send me an email and I will respond to you with a homework. It's probably gonna be something along the lines of, again, like an interview question, something simple that you guys can do where you need to create a test and then the function so you can test your function. But it will probably use more, you know, of the things that we learned. So things like, you know, either the string object or combining certain things, maybe even the requests and the string. So I'll basically tell you the steps, but it will be more along those lines. Sounds good?
Sounds good.
Okay.
Yeah.
All right. Any other questions, comments?
Yeah. Are we gonna have our class Monday and Wednesday? How it planned before?
No, it's Monday and Thursday. Not Monday.
Thursday. Okay.
Monday and Thursday. Yes, consistently Monday.
Okay, got it. Thank you.
Mm-hmm.
And every time, it will be every time 4 hours, right?
What do you mean time for a break?
I mean, each class will be 4 hours.
So
4
it's
hours
actually
Monday, 4 hours Thursday.
So it's actually about 3.5 hours because we take a break, and I also usually finish the class a little bit early so I can answer your questions. So yeah, more or less.
Thank you.
Usually I don't end at 11:15. Usually I end about 10:30, 10:45, something like that. Mm-hmm.
Is that okay, appropriate to ping you in Slack and asking questions, or?
Absolutely.
Better?
I'll warn ahead of time. I do have a full-time job and I'm also a mom, so I don't respond right away. So if you really need an answer from me, be persistent. Essentially, like ping me several times. You know, if you
No
send
need,
me a
okay.
message, if you don't hear back from me within 24 hours, just send another message, because at that point I'll be like, oh my gosh, I feel so bad. I need to respond to this person immediately. Versus sometimes I get lost and forget things. But yeah.
48 hours. 48 hours is totally fine.
Yeah. All right, you guys, on that awesome, happy note, I wish everybody a good night or good morning if you're in Germany. And yeah, I'll see you guys on Monday. So bye, everyone.
Thank you. Bye.